Okay, thank you. So, so with that, let's get started. So again, we're very excited to have you here today. Thank you for joining us from wherever you are in the world. This is a global conference, and you're here with us today with your morning coffee or lunch or dinner, depending on from where you're joining us. You are now a part of the global community that's passionate about data science, innovation, inclusion. So we're privileged to have you all join us. Please sure to connect with us on social media. Use our hashtags with Silicon Valley and WITS 2025 to share your thoughts, your favorite moments, any golden nuggets that you get from the speakers' presentations, and please shout out to the incredible speakers that we have throughout the day today. So that will help us, outreach and increase visibility for our speakers and our conference. So we appreciate you doing that. I will go on to the next slide, which is our incredible event. This event that we have put together over the 4 days, over 2 weekends, would not have been possible without all our volunteer and co-ambassadors here. So my name is Nishreen Kachwala. I'm the WIDS ambassador and today's introductory host. And I'm joined by a team of women in data analytics and leadership. So just wanted to acknowledge and thank Tuini, Karpagam, Jasmine, Arti, and Madhuram for all your hard work and creativity to make this event a truly global and inspiring. Getting the speakers, getting everything aligned, setting up posters and what else that goes behind the scenes in putting up an event like this. So we appreciate just showing appreciation for the team here. Our agenda for today, we have an incredible lineup of speakers, from practical AI workflows to science behind menopause to predictive ML in aviation. And it's not just about tech, it's how about the data shapes our world and how we as a community lead with insight and intention as well. So we'll kick off things with a very short WIDS video, which we are encouraged by WIDS to present to our audience, and then dive right into a speaker. It's a very short video, so please bear with me. We are a part of WIDS Worldwide, and this is their vision and what they do. I will not speak to that, but they've done an incredible amount of work in bringing together this community and educating and empowering women in data science. So let me just go through this short video from WIDS.
Women in Data Science Worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world.
WIDS has grown organically, responding to what the needs of the community are, what women data scientists need, and exploring new ways to interact. Stanford University is proud to have been the birthplace of WIDS and a decade of growth. With our unique strength in data science, computation, and AI, Stanford was the ideal incubator to support this force for advancing diversity in data science. WIDS has had a lasting impact on data science at Stanford, with a co-founder of WIDS as a founding member of Stanford Data Science. Including multiple perspectives is baked into the core identity of our programs.
It's critical, and we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
Because it really fosters that sort of community building you want when it comes to not just data science, but really any, I think, efforts to try and engage more girls and women.
So the fairness mission that we have is really try to enable that two people with equal talent should have an equal shot at opportunities.
I also just encourage people not to give up and keep arguing for what you believe in and what's important to you and what you think will make a difference.
WIDS is about the sense of urgency we should all feel to ensure that women earn that seat at the table based on their skills and talent across the world.
WIDS has inspired me to believe that more is always possible.
WIDS has inspired me to think big.
WIDS has inspired me to learn more.
It brings together some of the leading scientists in the world.
The journey is just beginning. At WIDS, we're not just envisioning a more inclusive future in data science and AI, we're making it happen. From equipping students with critical skills to advancing career development, we're expanding access to education, mentorship, and empowering support for tangible impact. The next decade starts now, with action, with us. Join us in shaping the future. Volunteer, mentor, or donate today.
Thank you. And that's what WIDS was about. So let's go ahead and roll the, the conference, and I'll hand it over to Arti to introduce our very first keynote speaker, Rama Akkaraju. So welcome, Rama. We're looking forward to your talk, and super excited to have you here.
Thanks, Nishrin. Welcome, Rama. And it is my honor to introduce Rama Akkaraju, VP of AI at NVIDIA. To say the least, she's one of the powerful women in AI, a multi-award-winning and industry-recognized artificial intelligence leader with a proven track record of delivering enterprise-grade innovative products. Rama is a former IBM fellow, one of 300, just so you have the numbers here, one of 300 in 100 plus years of IBM history. It's very prestigious. IBM Master Inventor and former CTO for IBM Watson AI Operations product, led and delivered several cloud-based AI services that model people's personality traits, emotions, communication tones, and sentiments, serving billions of AI API calls. Scaled natural language understanding, NLU technology, automated speech recognition, ASR technology, and voice recognition technologies into product offerings. Forbes 20 Top 20 Women in AI Research award given to her in 2017. Top 6, A Team for AI by Fortune Magazine. 2018 award, Top 10 Pioneering Women in AI and Machine Learning by Enterprise Management 360, 2019. Rama has an MBA from NYU Stern School of Business and a master's degree in computer science from Utah State University. Her keynote today is on the topic of continuous improvement to AI workflows. It is my pleasure to welcome her again. And thank you, Rama, for taking on this activity with WIDS.
Thank you, Arti and WIDS, for having me. It's a pleasure to be here. And as I was watching the video, I was realizing my association with WIDS. I've been with Women in Data Science with Stanford right from day one. And I know Margot very well. And I even gave one of the keynotes at the second WIDS conference, I believe. So it's always good to come back to WIDS forum. And I have seen it grow from almost, that one single conference that happened at Stanford that I attended to what it is now, which is a worldwide phenomenon. So it's so wonderful to see a community that grows up right in front of your eyes to such a worldwide phenomenon. So kudos to Stanford team, Margot and others, and to you all for continuing to nurture this community and help it grow and bring the community together. All right, so let me get to the main content. I'm going to share it here and putting it on screen share mode. It's always a little iffy when I have a monitor here, and tell me if it's showing, or if it's not, then we'll adjust accordingly.
Yeah, we can see your screen. Yeah.
You see it in full screen mode?
No. Screen sharing mode with the speaker notes.
Oh, I see. Okay, that's not good. Let me see what I can do to swap it.
Rama, at the top left, there's a swap displays.
I know, I'm trying to get to
Button.
that.
Oh, okay.
It's also the
It's always tricky, this part.
let me do this just very quickly. Stop sharing. My video has gone out, huh? Let me do that. Okay, sharing again. This should work, hopefully, this time.
Perfect.
How's that?
Yeah, perfect.
All right. Okay, let's get started. Well, I'm going to be talking to you about how to improve AI models and AI workflows and agents once you put them in production. So this is an interesting one because I'm not going to be today talking about how to build AI agents and how to deploy them and all of that. That's what we've been talking about for the past 2 years, right? So it's about time when some of these AI agents are deployed in production, or chatbots and copilots and such. And we want to really have them improve from where they are at. So I'll focus more on that improvement aspect of it. But if we were all in a room, I would have asked you this. How many of you have interacted with a chatbot that always gave perfect answers? And the answer is, I'm sure, no. Uh, Even the best of the best models and the chatbots or systems, including ChatGPT that's out there, powered by GPT 4.0 or 4.0 plus, 4.5, whatever you pick of your choice, still makes mistakes and hallucinates, and that's how it is. So the question is, how do you improve these to specific domains to get to the levels of accuracy? I'm not just talking about chatbots, I'm talking about any kind of AI agent or an AI workflow that you build. Anything that, it's like a child's journey. Any agent or any AI workflow or a chatbot that does not learn is like a kindergartner. It's always stuck at one level and is never going beyond that. So the world is moving fast around us, and the data in our companies and our enterprises is continuously getting updated and changed and all that. And the foundational models that are built using all public domain knowledge are never going to be able to have access to the data that's tucked away inside the company boundaries. So some of the interesting challenges as we try to apply these AI agents and chatbots to a company for solving company problems is first of all asking questions about how do you give access to these systems, enterprise data, so that they are able to really perform tasks on your enterprise data. And once you build and give them that ability to access enterprise data and all of that, how do you ensure that they are continuously improving? Because the foundational models are foundational models. They're improving too, but they're improving based on public domain knowledge. They don't have the knowledge of the enterprise. Now, as the enterprise data is dynamically changing, you have to ensure that this this change is also getting reflected on the models that you are using, so that you are getting the best out of not only the foundational concepts but also on the enterprise data. So this talk is going to be about building those what we call as data flywheels or continuous learning loops to improve chatbots or copilots or AI agents, the first generation of them that you have deployed in your enterprise. Well, AI agents are buzz these days. Everybody's talking about it, and rightly so, because they have the potential to significantly transform enterprises in many ways. From what used to be many tasks that required human intervention, we can now imagine AI agents doing them automatically with the power of LLMs, the large language models, and the ability to plan, reason, critique their own actions, and access to various tools being uh, APIs that are are making available the enterprise content, or other AI agents, right? As you bring them all together into these workflows, you can now imagine building these powerful solutions in the enterprise, such as research assistants that can do a lot of research for you, or customer service agents that automate some of the customer service tasks, or agents that do your security reviews for your libraries or software, many kind of things, video analytics and search for surveillance and many different use cases in the enterprise. So AI agents are here to transform the enterprises. So the question now is, how do we really leverage them? So knowledge assistant / customer support agents have been one of the first kind of use cases that have been used in the industry. Right from the initial early days of natural language understanding, even before ChatGPT came along or GPT models came along, we as a community of AI engineers and data scientists have been trying to understand the intent of customers, and through dialogue flows or dialogue trees, try to create these chatbots. Thankfully, we don't have to do that. Intent understanding has become much more powerful with the large language models and GPT models. But today, what I'll do is I'll take you through some of these, starting with knowledge assistant agent as a category, to talk you through some of the challenges of improving them. So you build one, let's say, and you deploy it and put it in production. What are some of the kinds of mistakes they could be making, and how do you improve them? Is going to be the topic for the rest of the discussion here. So our journey at NVIDIA has been very similar to how the industry has been going. We started out with chatbots as well. So I'll take one of the chatbots that we've built at NVIDIA as an example to talk you through today. This is our intranet chatbot that sits on our intranet. It answers various kinds of questions. We built it. You could ask it HR benefits types of questions. You could ask about NVIDIA's financial earnings data. You could ask about IT help questions. You could ask about NVIDIA product documentation, NVIDIA policies, NVIDIA holidays, and many more. So for example, take HR benefits question. How much does NVIDIA contribute to healthcare savings account plan? This is a very typical question everybody asks, every new employee asks, or right around the time when you are trying to make your benefits decisions. People can just come to this bot, they ask the question, and it pulls up the response for you right there. And will provide the citations and references, so that if you wanted to go dig deeper into it and understand more details, you can access that data. Or you can ask the one at the bottom, IT help question, right? I'm a work from home employee. How do I order my monitor? Again, you get an answer right away and a link to various things that you can answer. Links is only the starting point. We are increasingly starting to actually accomplish the task right there. So you want to ask, order a monitor? All right, right there in the chatbot, you can actually, it says, oh, you got one. Are you trying to update it, upgrade it? What is the kind of monitor that you want? These are the available ones, and just go fulfill your task. And I'll now talk about the product documentation. You can ask about what is NVCF? This is a new acronym as a new employee that I ran into. I have no idea what that is. Oh, yeah, then the system comes back and tells you, well, NVCF stands for NVIDIA Cloud Functions, and here is how you can learn more about it. And then the kind of financial earnings questions, which are very, which can be very, I would say, multi-part questions or complex questions, like what are NVIDIA's data center revenues for the past 3 quarters, and what factors contributed to the growth? This is a complex question. So it's not a simple go to one document in the enterprise database and do the retrieval with the vector database, retrieval augmented generation, and fetch the data and answer type of a question. Because you're asking for revenues for 3 quarters. Typically, revenues are released in each quarterly data, and it's in 3 different documents. You have to go fetch that, understand that the question is about 3 quarters, do complex query decomposition, fetch the data, assemble it, make a table out of it, and then not forget to answer the part 2 of the question, which is what factors contributed to its growth, which is an analytical question. You now have to analyze all of this data and any kind of commentary that's provided during earnings, and from that distill and answer the question on what factors contributed to it. And you see that the growth factors are also listed in the table. So the way we are able to answer these questions is because we built agents. An agent, it's actually, the architecture is a mixture of agents. That is, you'll see that what we have is a set of experts. Each expert is good at answering questions on a specific subdomain within the enterprise. whether it is an agent that's really good at answering NVIDIA policies or on NVIDIA's financial earnings, or an agent that can answer on company information, or an agent that answers all things about holidays and in different countries and such. And another one that is good at answering about IT help, HR benefits domain, and so on. Because each subdomain within the enterprise comes with its own nuances and vocabulary and all of that requires careful tuning of your prompts or your the models if you're fine tuning them, and the guardrails and all of that. So that's kind of how we built it. So the overall architecture for the bot, what we call as NV Info bot, looks like this. A user comes and asks a question to the bot. They don't know that there are multiple experts, agents behind the scenes working and all that. They just come to this place and just ask a question. There is an agent, a router agent that sits up front and is able to, based on the question that the user asked, figures out to whom to direct the question to. Sometimes it's a multi-part question, and maybe the question crosses across policies or holidays, and in which case the router does the assembly as well. It's not a simple router, but it's actually doing orchestration. Now, each one of this is a complex retrieval augmented generation based pipeline in itself, and a complete AI workflow in itself. I am expanding only one just for the sake of simplicity here. The way it goes is, let's say somebody asked a company information related question. It goes into this vector database into which we have ingested all of the data, and the content is vectorized, and there is a retriever that's powering the answers, retrieval of the responses from the system. First, the query itself is rephrased in case you have dates and ranges and all of those kind of things. It's better to always rephrase the query, or multi-part question. You break it down into what are the revenues for the past 3 quarters, could be broken down into the past 3 quarters, quarter 4 of 2024, now quarter 1 of 2025, quarter 2 of 2025. These are the 3 different quarters. So you break it down into the subparts so that you can actually retrieve relevant documents. So that's the query rephrasal that's happening. Then you retrieve the documents, chunks. Typically, it's chunks that you're retrieving. You re-rank the chunks of data, and then you put it together into automatically into that prompt, and then finally send it to an answer generation LLM, which takes all of the retrieved chunks and generates a response. And then you have the citation pipeline that generates the citations for you. This is a typical retrieval augmented generation workflow for a chatbot you can imagine. And so each one of it is a pipeline like this. Now let's get to the main topic. I told you about that this topic is about how to improve the AI agents when they make mistakes. So when we deploy a pipeline like this, we measure the accuracy for each of the agents and for all the questions that the users are asking on a test data set. And we said, okay, we are at close to 89, 87% accuracy. That's acceptable. We'll go to production. And we went to production. But we know that there is that 10% improvement we can do. And so we have to continuously see where we're not doing well and make plans for improvement. So the way we do it is by collecting user feedback data. All the questions that the users are asking are logged, and we analyze that data. Now, when we analyze that data, if you look at the pipeline itself, we already know, even going into production, that there are many failure points in a typical retrieval augmented generation pipeline. So a failure point is a place where an error could occur, where things could go wrong, which leads to an inaccurate response. So I just listed some of them. There are many more. In a paper that we've written, actually, we call out about a dozen plus failure points. But let's just quickly look at this one. A router error could occur because the routing or orchestration is being done by an LLM. LLM itself could make a mistake in understanding the intent. And sometimes, especially when the domains are somewhat closer to each other, like the NVIDIA policies versus NVIDIA holidays versus company information. Sometimes there could be a little bit of overlap, and it could make mistakes. So there could be a routing error. Query rephrasal could have an error. Again, query rephrasal is also done by an LLM, and it could make a mistake. Sometimes it could make a mistake in interpreting quarters, for example, or a financial quarter versus a fiscal quarter versus a calendar year quarter, and it could make mistakes like that. So there could be a mistake there. The retrieval system, vector database, and the retrieval could make a mistake. It could be because your vector embeddings are not quite matching the domain, and therefore your semantic similarity scores are not quite there, and so there could be mistakes in retrieving the most suitable relevant chunks. And the re-ranker is an LLM, and that could make a mistake in interpreting which one is highly relevant, and therefore some of the relevant chunks could have actually gotten filtered out. LLM itself, finally, answer generation, one could make a mistake. There could be either hallucination or just the LLM is not a powerful one that you have chosen, and its ability to summarize is not quite there. Any number of things could happen there, and it could be a mistake. You could have answered the whole thing correctly and still provided incorrect citations and the links. And that could happen when you have enterprise content that's not fully updated in a company. Sometimes there are multiple documents that talk about the same thing. That happens all the time. People create multiple Confluence pages that have similar content. One is an older one is a newer one. And even if you give higher priority to more fresh content, you could end up with the citation documents that pointers to documents that are older. And there could be, links that you generate that are not working. Any number of things could occur. So these are all real errors that could happen and that do happen. So here is a framework that we introduced to effectively improving the agents that you deploy to production to build these continuous learning loops. Now, this framework is nothing new. It's borrowed from control theory that's been there for quite some time. You could argue that actually nothing is new as such in the field of computer science. Everything comes back around old wine in new bottle. A lot of concepts that we use today are really recycled concepts from distributed computing and control theory, you could argue. So I said, well, there is no need to go back and reinvent one. Let's use the control theory framework and reimagine it and apply it in the context of AI agents now. So the control theory framework goes MAPE, M for monitor and monitoring user feedback. So for any system, if you want to improve it, there has to be a control, feedback loop, and that's what this framework is about. How do you build a control loop? You first the improvement loop, feedback loop. You first monitor the user feedback data, see how well the system is doing, analyze the errors, where is it making mistakes, and attribute those errors to specific failure points. Just generally saying it makes a mistake there, let me improve, is not going to work. Just the way when a child makes a mistake, you in a math test, you go and examine what kind of conceptual gaps that the kid has, right? Is it long division? Is it multiplication? Is it just the table? Multiplication memorization itself is not good. What is the root cause for the problem, and actually go tackle it by giving many more examples for the kid to practice, and that's how you improve it, right? So you have to kind of pinpoint to the particular problem, the root cause of the problem, and that's analyzing the errors and attributing them. And then plan the improvements, right? In the case of an improving kid, you just plan and provide many different examples, or maybe get them to join Kumon and do the practice problems in specific areas and whatever. So that's the planning. And finally, once whatever plan you come up with, you execute. So the rest of the talk, I'll talk you through each one of these things. So how do you monitor? Well, when you build a chatbot, you have to collect user feedback. That is how you get the feedback from the users. So we do. And users have the ability to give thumbs up or thumbs down. And when they give a thumbs down, they have the ability to tell us whether the answer quality was not good, was it incomplete, incorrect, or the citations were not good. So that's good. So we collect all this data. So in this particular example for this analysis today, I'll talk about the data that we've collected. I'm going to be talking about close to 500 thumbs down data. Let's look at these two examples. I'll talk through these examples for the rest of the talk that failed. And our goal at the end of this talk is to get these two queries that failed to actually improve with the feedback loop. One question that users asked is, what is the role of RESS planning team at NVIDIA? They ran into this acronym, maybe they're trying to understand. It so turns out that RESS actually stands for Real Estate and Site Services, but the system came up with unable to find a response, although there is a document that talks about what role Real Estate and Site Services organization plays. Somehow, the reason why it failed is because the system interpreted, or LLM, with its own creativity from external knowledge, interpreted RESS to stand for Resource Planning Team. And it was looking for documents that had something to do with Resource Planning Team, which did not exist. Therefore, it came back and said, unable to find an answer. Second, somebody from Canada asked, how many vacation does NVIDIA Canada have? And there is a knowledge article that talks about it, but somehow it was not able to find the answer. So let's examine where things failed. And our goal is to build the continuous learning loops to improve these so that these kind of questions can be answered accurately. So let's put MAPE to test. So we just did the monitoring and user feedback. So we collected all the user feedback. We got all the data. So now we got to analyze the data. So as part of the analysis, I've already talked about this flow, and now the question is, for the failed queries, where are the problems occurring? Which part of the pipeline is the problem occurring? Because there are many failure points. So in order to do this, we first need to look at all the errors and classify them. So we built a classifier model where we take all the error types and the prompts, and we have a model that looks at them and say, could this be a router error or a query rephrasal error? Why is that the case? So when we look at the logs, we capture all the logs at every step of the pipeline here. What was the query? What was the route? Where was it routed to? How was the query rephrased? What was the response of the retrieval? What chunks were retrieved? How was it ranked? So when we put all of this data in the original query and again put an LLM to use and say, hey, classify this into where this could have gone wrong. And this model at least helps us in an automated way to classify the errors. So once we have the classification of the errors, we know where the problem is. So for, let's say, today we're going to talk about two things, one, the router error and the rephrasal error. So let's first look at our error analysis. These two queries that I talked about were correctly grouped into the corresponding errors. The first one is about a rephrasal error because it asked for a resource planning team instead of real estate and site services. It was not able to get a response. So it was rightly classified into rephrasal error. And the second one was routed to the wrong kind of an expert that did not know the answer. It should have been routed to policies expert, but it routed it to holiday expert. For some reason, vacation days is a policy. It's not which days are holidays in Canada. So it kind of got confused. So if you say, what are the holidays this year? That should go to holiday expert. But how many vacation days for Canada is a policy for Canada country. So it's a slightly confusing domain experts, overlapping content, and could be that's why that happened. But still, nevertheless, we wanted to fix those kind of routing errors. So at least now we have a categorization. All right. Now let's look at how do you plan the improvements. We know the challenge is it's a router problem or a rephrasal problem or whatever else, right? I only talked about the two just for the rest of the discussion, but there could have been any one of the 12 places where things go wrong. So we now need to figure out a more general purpose framework that will help us to, in a more automated fashion, address those challenges. So here is where somewhat of a shameless plug. I'm sorry for that, but because this is what we used, so I'm going to talk about it. We used our own NVIDIA's NeMo, which stands for Neural Model Microservices. The idea is that we have a series of these frameworks and tools that are available for doing the data flywheels, building the continuous learning pipelines. So you have to do data processing, that's using the curator. You have to figure out if you need to customize the LLM model with enterprise data, do the model customization. Then you have to evaluate on your data sets to see make sure that there is no regression on the previous ones, and that these errors that we are now trying to address are fixed. And then if there are any guardrails that need to be applied to make sure that you're not leaking any sensitive data, do that. And then finally deploy the model. So that's the continuous learning loop. And you have to continuously keep on doing that, because there is nothing like 100% accuracy. And even if you achieve 100% accuracy today, tomorrow it could go down again, because the data changes, and unless the models are continuously adapting to the new data and the new content and all of that, the accuracy could go down. So this is a continuously learning process. And that is the interesting part, right? Everybody's in the industry is so consumed about talking about how to build, which is good, because that's where we need to be in the first iteration, first few years. But once you go to production, this continuous learning loop is what is needed. Otherwise, people give feedback and they say it never improves, and it kind of gets stuck at that level, and they may not use it. So here is the flywheel concept. The same architecture now has, with all the feedback data coming into this bottom layer of data flywheels, where we end up leveraging all of these ideas, automated set of tools to continuously improve, which includes automatically taking the feedback data, that's the data ingest, into the intake service, for example, and then some kind of a human in the loop. It's not a completely automated system. By no means I want to paint an image that everything is automated and you just click a button and things kind of keep on going in continuous learning loops and accuracy keeps on going. This is too dynamic and too much of a complex system that requires human judgment at right points in time. So it's a human in the loop system. So here is how we ended up doing this. Our NV info, our intranet chatbot data, user feedback data has all been ingested into this tool, which tells us what was the positive feedback, what is the negative feedback, and some of the key findings summarized. Again, along the way, lots of LLMs being used even to do the analysis of the intake, the data that's been taken in, and the analysis itself is powered by LLMs. Then we take all of the data and the corresponding user prompts and the completions being the responses that were generated, and humans annotate why did this error happen? Is it that the knowledge article did not have enough information, or is it because the system got confused? Whatever, right? The user gives that corresponding feedback, user being a subject matter expert in each domain. And all of that data either is going into our updated evaluation data set or into the data set that we will use for doing model fine-tuning. And then we use the tools to kick off a fine-tuning, model fine-tuning, if model fine-tuning is deemed to be a solution for this. Because I don't want to, again, give the impression that model fine-tuning is the hammer to hit for every nail. In some cases, you may simply need to fine-tune the prompt or update the prompt or give more examples in the prompt, like in-short examples. And in some cases, you may need to improve the retriever. So there could be many number of reasons or techniques for improving it. I'm specifically calling out the model fine-tuning one here for illustration purposes. So you kick off a model fine-tuning job with the annotated data. So once you give these user feedback examples to the system and say, I'm going to fine-tune a model, that fine-tuned model can now become the new model instead of the original foundational model, which may or may not have had enough enterprise knowledge or context to improve. So now let's talk about how the execution works. So we had about 1,000 plus user feedback data across many things, and I'll talk about 2 steps that we are fixing. We took the thumbs up and thumbs down feedback data, and here are some statistics on how the experimental setup was done. Took they split it up into 60-40 for train and test, and the ground truth was created. We are set up to use LLM as a judge to assess the, when 1,000 plus feedback comes, we can't be sitting and looking at each one and say, is this really the problem or not? And so we just take all of that data sometimes users don't give thumbs up, thumbs down. So we take all the user queries and automatically do the classification that this is correct, this is not correct as well in some cases. In any case, when we take all of that data, we build the fine-tuned model. We do the fine-tuned model and we run the results. We got an interesting results to look at. Originally, we used Llama 3.170b for doing the final answer generation. Its accuracy, I'm now talking about the router. Its accuracy to start with was 96%. It was doing a pretty good job. We're only trying to improve the rest of the 4%. And the result was interesting in the sense that we used, you see that Llama 3.18b instruct model, which is the blue line, and then Llama 3.23b instruct model, which is the orange line. These are much smaller models than the 70b model, and they're able to get pretty close in accuracy, same 96% closer to that on the same data set. So, well, I wanted to improve the accuracy as part of fine-tuning. We could have fine-tuned the Llama 370b itself, but that's much bigger model, and fine-tuning such a big model on a regular basis is too time and compute intense. So we really wanted to actually work with a smaller model, and what this result told us is that we could get to the same level of accuracy with a much smaller model. Okay, that's a great result. I could take that. It didn't help me get to a better accuracy yet, but I am able to achieve the same accuracy with much lower latency, which is about 0.26 seconds versus now I can do this same all the routing in 0.08 seconds. Okay, I think I'm in at least in a ballpark space of much better accuracy and comparable accuracy. I can further do prompt tuning and fine tuning to now improve it. So this was a good result, although I had hoped to get to a better accuracy. It still is a pretty good result to get started with. Much smaller model. So now we wanted to do error analysis on how, if we did that, actually, by the way, it so happened that this error of what is the role of RESS, this particular query, now got fixed because the model has learned, based on some of the feedback and the terms of the within the enterprise, and it's able to do the rephrasal of this a little more correctly. Now I want to address but I still didn't improve the accuracy. So I want to get to that point. So we ran the second experiment to say there could be a problem with rephrasal as well. So I want to fix those things. Again, took that the thumbs down data, scrubbed it, augmented it with some synthetic data that we've generated, about 5,000 samples with synthetic data generation pipeline that is automatically generating some made up examples that kind of represent the thumbs down and some thumbs up data, so that we have enough to go around to fine tune the model that does the query rephrasal. Now, when we did the query rephrasal, you can see that the bigger model, Llama 3.170b, was giving us 73.8 accuracy, whereas a much smaller model, Llama 3.18b model, which was fine tuned, is now at a higher accuracy, 77.5%, with lower latency, which is exactly what we want. We are always shooting for higher accuracy and lower latency, so that we can get back to the user with answers, higher quality, more accurate responses, much faster. So this is definitely a better accuracy and better result than what we started out with a much smaller model. So we now went back and reran some of the two queries that were of interest to us and checked to see if those problems were fixed. And voila, they were fixed indeed. Clearly, I mean, you could say, rephrasal accuracy is still at 77%. Why is it not closer to 90%? We'll get there hopefully one day with more iterations of improvements and such, but this is the life of real enterprise agents. It's very hard at every step of the way, where if you have a pipeline with dozens of LLM calls, which most of the complex enterprise agents do, for each one to have 100% accuracy. No, it doesn't work out that way. So you start somewhere there, a combination, some have 80%, some have 90%, some have 77%, some have somewhere in the range. When you put it all together, hopefully the overall accuracy is somewhere above 85 to 90%, good enough for you to go to production with. And then you have to continuously improve with a slog fest very careful, methodical, human in the loop, as well as automated tools to improve. And anyway, coming back to this point about how to improve, what happened to the examples, we were thrilled to see that now the system is able to actually correctly interpret RESS acronym to really mean real estate and site services. And because there was a knowledge article, it was able to really find the right question, right response, and answer the question of what is the role of RESS planning. And the answer comes back like this. The role of RESS, real estate and site services planning, is to manage all the day-to-day site operations, support lease and project delivery and those kind of things in the company. Basically, they're managing the buildings in the company, our Santa Clara buildings, headquarters buildings. There are, 7 or 8 buildings in the Santa Clara area, how they manage all of those, and in different countries around the world. So the answer was correct. And for the how many vacation days does NVIDIA Canada have? Thankfully, again, this time it figured out that this is a policy question because we were able to fine-tune the model, the router model, right? Although the accuracy seemed the same, 96%, it now picked up some of the enterprise content and the vocabulary and the nuances between different things, and it was able to really route it to the right agent, which was answering questions on vacation policy and was able to pull out the right link. So that's a great result. So I'll sum it up by saying this is been an interesting journey to not only build, because the past 2 years for us has been the journey of building our first iteration of chatbots, copilots. And I took one of the chatbots that we built for our intranet and the complex pipeline of retrieval augmented generation. How do you construct it, and what are the various failure points? How do you really tune each one of those failure points before you go to production? And we've written papers about that and talked about that in the past 2 years. The time has come now, once you go to production, right? How do you continuously improve? So that's the work that we've embarked upon. And here I shared with you all a framework called MAPE, that is to monitor user feedback, to analyze and attribute failures to specific points in the pipeline, to plan your improvements accordingly, so that you can very specifically, in a methodical and a targeted fashion, address specific problems in each iteration of improvements, and then execute those improvements automatically. Now, I did not talk too much about when we fine-tune the model, how do you actually, what is the process? The process would be that you have to now you host this model, you replace the endpoint pointing to whatever fine-tuned models from whatever the production models are. You have to do all of those things carefully and then track the usage again and the latency and the monitoring and all of that, and go around for the next iteration, and so on. So that's kind of the pipeline. MAPE, hopefully easy to remember. And here is the overall architecture once again, where you have multiple error points and you go through each one of the error points methodically with a fine-tooth comb, human in the loop, but using lots of automated frameworks such as the model fine-tuning framework, user feedback analysis and error classification and categorization, and automated evaluation pipelines. And all of these things have to be put in place for you to be able to execute this data flywheel continuously. Hopefully this has been useful and helpful to you as you think about deploying things to production, or if you have already deployed your pipelines to production, how to go about to continuously improve those models. So I'll pause there. I know we are at time. I'll hand it back over to you, Aarti.
Yeah, thank you, Rama. And this is a very useful use case and a very real problem that I'm sure, like NVIDIA, other companies also face. And being in that space, I can tell you that, how do you continuously improve the AI workflow so that you provide the responses with low latency and high performance is a challenge a lot of companies have, including Sambanova.ai. My question with regards to the MAPE framework that you shared is, what are some tools that you used as part of the various phases in the pipeline? You talked about data ingestion, you talked about data validation, human in the loop, and also deployments. I'm envisioning a cloud-based setup where the endpoints are readily available to the NVIDIA employees where they can query and get results back. It'll be interesting to understand the tools, vector databases inclusive, that NVIDIA used in that pipeline.
Yeah, good question. I didn't go too much into the deployment the architecture of it, but you've highlighted many of those things. Yes, we have our own LLMs. So all these Llama models, which are public access models, are inference optimized with NVIDIA's Tensor Real-Time RT called TRT LLMs, and they're hosted via NVIDIA Cloud Functions, and they're available to all of us to leverage. And in fact, they're available to everybody. If you go to build.nvidia.com, all these LLM models are available and you can access them. And that's how many people are using them for exploration and deployment, production deployment. But we have, yes, an internally hosted set of models that are available, and we can request either private endpoints or shared endpoints. Typically for production loads, we use private endpoints, and we have control over then fine-tuning those models and redeploying the fine-tuned versions of the models and pointing back the endpoint URLs in our deployment configuration files to the updated versions of the models. All of that is managed through CI/CD pipelines. So all of that happens as part of the automated build pipelines that we've built. With regards to databases, we currently use Milvus vector database that is hosted internally. And there are many more nuances that I did not go into, which include another vector database, Glean, that we use, which honors the role-based access control. And there are enterprise content security APIs that we have built that have classifiers in itself to protect sensitive enterprise content, because sometimes by mistake, if you have confidential documents made available, these powerful tools will go after everything and start to summarize and give you information from those documents as well. So we detected some of those kinds of challenges early on as we went to production, and we built again LLM-based AI agents, which are available as tools or APIs, which provide the necessary guardrails so that we use those before the final answer is presented to the user. So there is a whole deployment architecture story to all of this behind the scenes than the data science story that I had shared today.
Yeah, thank you so much. This all makes sense. There are several other questions, and certainly running out of time here. Rama, thank you so much for taking the time this morning and presenting about the data flywheel architecture for continuous AI workflows improvement. And if there are any further questions, I'm happy to interact with you offline and get those answered.
Thank you so much, Aarti, Nishrin, and the Women in Data Science team, and have a good rest of the conference. I'm going to hang around a little bit to answer questions in chat, but continue on with the rest of the program. Thank you once again.
Thank you. Nishrin, over to you next.
I think you're introducing Monica.
Yeah. Thanks, Aarti, and thanks, Rama, for the wonderful keynote session. Our next speaker is Monica, who's the founder of Nerd Nourishment and instructor at LinkedIn Learning and the host of Data Podcast for Nerds. She specializes in helping professionals leverages data analytics to make their lives easier and thrives in the intersection of audit, analytics, and education. She has helped professionals transition careers by building personalized roadmaps, consulted with internal audit teams to build data driven audits, and is very passionate about working as an instructor to empower professional development. So, over to you, Monica.
Thank you so much. All right. Let me go ahead and share my slides. Okay. Can we see everything all right?
Yes.
Yes? Okay, perfect. So thank you so much for having me here. I'm excited to have the opportunity to talk with y'all today, this morning, this afternoon, this evening, wherever you are located. Today we are going to be talking about using analytics and AI to improve the quality of audits. And I want to go, I have this slide just to go a little bit about more about my background, but I want to give everyone a chance in the chat to please share where you're coming from and what you do, whether you're in university, you have a role at a company, or you work for yourself. I'm interested to learn more about the audience. So, speaking of where we're located, I'm located in Arizona. I love the desert here. It does get a little bit hot, but I really do love the heat. I went to university at the University of Arizona, where I got my accounting and management information systems degrees, and that kind of landed me in an IT auditor role. And so a lot of my 15 years of experience is in that audit space in the overlap of security, risk, and compliance. So basically testing companies to make sure things are working as they should be. And I do have certifications. I have my CPA, but I don't do taxes. I do also have my CISA and my CISM, which are those security related auditing type certifications. And as mentioned, I work for myself at my company called Nerd Nourishment, where I'm the founder and chief data enthusiast, as I call myself. And I provide audit analytics and AI services for internal audit departments. And I also provide career coaching for folks that are transitioning from kind of a non-traditional background into the data field. And I'm also an instructor at LinkedIn Learning. I love teaching others about all the things data related, audit related. And I have a podcast if you want to tune in and hear from all kinds of different data professionals and learn how they're basically using data to solve the world's problems. All right, so we have people from California in data science, data analysts, data engineering, the whole caboodle. Perfect. So a lot of California folks. Okay, love Sedona. Sedona is amazing for hiking. Yes. Okay, perfect. So we have a good mixture of folks. However, I do want to go over a quick definition of the audit space. I do know that auditing is pretty niche, and there might be folks out there that might not be familiar with audits. So we'll first start off with the definition there, because a lot of people actually think that audits are just really boring reviews of financial records with a primary purpose to find and identify fraud. And while that is sort of true, there's actually a whole lot more to that than just finding the fraud. Specifically, it's an auditor's job really to make sure that things are working as they should within a company, and also that they're contributing to the organization's overall ability to successfully achieve their objectives. And this actually requires a lot of testing. A lot of testing's involved for us auditors to do. And specifically, what we are testing are what are referred to as internal controls. And you can think of these internal controls as kind of rules that are put into place, not only to make sure that you aren't breaking the law, but also to make sure that the company's really working as what I like to call a well-oiled machine. And the internal controls are typically centered around things like people, processes, and technology. And so within this overall landscape, basically, you're making sure that all the employees have the appropriate level of skills and all of the knowledge to be able to learn all of the processes that are then used to operate the technologies that are supporting the overall business. Again, that well-oiled machine. So, with all of these things that we have to test, we hope that we can apply these data analytics and AI techniques to be able to speed up the process and also to improve the quality of the audits that we're providing to the business. But what might be surprising and unique to the audit field specifically is that it's not as easy as you might think. Yes, there's lots of, data professionals applying all of these techniques, but audit teams are actually still in the state of transition. So data analytics and AI aren't being leveraged by everyone quite yet. In fact, I found a trends report. It was a state of internal audit trends report by Caseware. And this one's from 2023, where they found that 56% of audit teams are using these analytics software as part of their regular auditing activities. And that's pretty small. That's only just above half of the audit teams that are leveraging the analytics software. But 34% of these teams don't currently use these softwares, but they do plan on in the future. So that's really good. Shockingly, maybe a little bit shockingly, 10% actually have no plans to use analytics. However, there are certain industries that do make it kind of difficult to be able to perform these tests in an automated fashion. So industries like, say, manufacturing or some retail companies do make it a bit more difficult for these audit teams to be able to leverage these technologies. However, I do think that with the pace of technology that we are seeing today, we will be able to get there. So I do have hopes for that. In fact, we're already seeing improvements here. I was able to get a hold of last year's report. So in 2024, we've already been seeing improvements just in that past year, which is fantastic. So you see that 56% is now 78% of teams that are leveraging these analytics software to help them with their audits. Fantastic. And we also saw a decrease in that 10% to only 4% now that have no plans currently to use analytics. But if it were up to me, I would do a world tour and get everyone on board. So that's my current mission. All right, but also, when it comes to AI specifically, I did find this other report. It is a Focus on the Future report released by Audit Board, and they found that only 4% of internal audit departments reported that they're making substantial progress with AI implementation. This is a bit expected, though, considering that with audit departments, they're typically really slower to implement any technology advancements because of all of the compliance and regulations that must be met. And also, we kind of feel out to make sure all of the bugs are kind of dealt with and all of that. And we know that we're not there yet, right? So we do kind of expect this slower implementation there. However, this actually really makes it a fun time to be part of the audit field as well, because of the fact that you get opportunities to build new things. Right. So for instance, I had the opportunity to build two data teams, one of them brand new from scratch. So it was a data team within internal audit. And so I was in charge of building out all of the methodologies and the procedures that drove the way that that audit team worked by leveraging those data analytic and AI technologies. And with another team, they had already kickstarted the data team, but I had helped develop and more solidify those methodologies and procedures. So if you are interested in the space of audit and compliance, this is a really interesting place to kind of get into a ground level type situation where you'll be able to make a lot of improvements. Also, I have had the opportunity to speak with audit departments that are leveraging AI currently, and they have already been seeing improvements specifically related to productivity along with other benefits. So, speaking of benefits, we'll go over some benefits specifically to how they relate to audits and audit teams. So, when you're leveraging these data analytics and AI technologies and techniques, what you will start seeing is that you will have an enhanced risk identification process. And so, what that means is before you start any audits, you want to figure out what risks exist within the company first so that you are able to tailor your audits and bring real value to the company. And that involves a lot of analytic techniques to be able to quickly identify those risks. You're also able to increase your efficiency. You're able to quickly analyze really large data sets. Companies have all kinds of data that they're collecting now, so audit teams need to be testing all of that data to make sure that things are working as they should be. And it should be able to quickly analyze all of this data is a huge benefit in the audit space. You're also able to improve your accuracy because you are not manually performing your tests really anymore. You're reducing that human error. My favorite benefit of all time is the broader coverage. So because of the large data sets that you have, and because you want to automate everything and lower that human error, you get broader coverage because you're able to test 100% of the population instead of in the traditional sense of auditing, when you're auditing, say, transactions for fraud. Typically, you would only take a small sample of the population and test those specific transactions, see what's going on there, and then you would extrapolate the results to the entire population and you'd call it a day. You can imagine you'd miss a lot of things that way, right? Because you're only taking a sample of those transactions to test. So with data analytics and AI, you're now able to look at 100% of the population, such as transactions, and be able to really understand what's going on in your environment and to have more of that accuracy in the results that you're providing. And then you're also able to provide deeper insights where you can explore patterns, trends, anomalies, which you would not be able to do in the traditional auditing sense by just looking at a spreadsheet. Nearly impossible to find any trends or patterns that are going on there. So when you put all of these benefits together, what you do is you improve the quality of your audits. So now I want us all to imagine that we're going to build the perfect audit. So we have access to all of the data. All of the data is clean. Again, this is a perfect scenario. And we're using the data analytics and AI techniques available to us. And I'm going to walk you through a day in the life of an analytics auditor to see how this works in our perfect audit scenario. So specifically, we're going to go over those real world examples showing different things or internal controls that you can test using those techniques. So first off, we have those risk assessments. I talked about this a little bit previously. This happens during the planning phase of the audit where you're gathering information about the company and how it operates so that you can plan your audit. And risk assessments specifically are used to identify either what systems or what departments specifically that you want to test. Another thing that people think about when they think about auditing is that we test the same thing year after year. Again, very boring, not very useful to the company. So these risk assessments and identifying these areas are very useful for the company to make sure that everything that is very critical to the business is working in the way that it should. And to do this, you can collect certain data like access logs and incident reports. So from access logs, what you're able to do is it'll show you who's accessing what systems, how often they're accessing it, how often those systems are being used, etc. Meaning that, say, a particular system is used on a daily basis by almost all of the employees, that would identify that that system is pretty critical to the organization. So you want to make sure that it's working all the time, every day, so that no bad things can happen. And then from incident reports, what that can tell you is basically like what systems are having issues or maybe vulnerabilities might exist. So say you have a lot of people calling in or employees submitting tickets saying that, the customer service desk is down or the customer service desk isn't really working appropriately. And if you have all of these incident tickets, if there are a lot of them, that could signify that there is an issue that needs to then be tested and figuring out root cause analysis and finding out what you should do to fix that system. All right, next test is with revenue fraud. Now this is a very common thing for auditors to test, basically to see if anyone's cooking the books, some might say. But rather than, doing that boring manual review of the financial records and kind of checking it against supporting documentation, you can apply a common approach, which in this instance, it's really good for fraud detection, is Benford's law. And what that does is find anomalies. And specifically, it's a phenomenon where the leading digit in a set of natural numbers is more likely to be a smaller number than a larger one. And so if you take all of your, say, revenue transactions and you plop them into a distribution plot, you'll see something like this. And say you see a spike at the number 7. What you want to do in that instance is look into it. This is something that auditors call a potential finding. And it could be an accident. There could be a specific reason for it, or it might indicate fraud. Basically, whenever you find any kind of anomaly, you want to dig deeper into it and go to management, figure out if they're aware of the situation, and if they're not, then even dig deeper to see root cause and what you can do about it. All right, next test is with expense fraud. Now, you might be familiar with this type of control where your company gives you a reimbursement for something like purchasing office supplies or maybe going to a conference. Auditors basically test these controls to make sure that the process is being followed, all of the expenses are legit, and that all reimbursements are approved. And so without the use of any data analytics or AI here, you're going to miss a lot of small things that could happen. So for example, we've seen where employees are submitting expenses that just aren't allowed. Maybe like they bought some clothing or some travel expenses that weren't allowed, and they're just hoping that management isn't really going to look deeply into this boarding documentation and just provide the approval. So there's ways that you can flag those inappropriate findings really quickly. Another thing that we've seen is that employees submit reimbursements that are just under the threshold, meaning that, say, all the company says that all expenses under $5 are automatically approved. And what you can do here is identify any one employee that's constantly submitting these types of $4.99 purchases per se, right? Not only do we need to figure out if these are even legit, but they could really add up and be a big risk to the company. All right, next example, control test that we want to see is vendor disbursement fraud. And this one's pretty unique. This is where an employee sets themselves up as a vendor, and that way the company is paying them for services that aren't being provided. Right? So here, things that you can test are with addresses. So you are able to, quickly match addresses, but where more advanced techniques come into play here is where you can use stuff like fuzzy matching. Or what's really neat is that you can actually turn those addresses into a geographic coordinate by using something called geocoding. And then that makes it way easier to then match the two really quickly, especially if you have a really long list of vendors. That makes that really easy to do. And then we have change management controls. This one's particularly interesting, especially for all of the developers out there, those engineers, etc., right? So changes that happen to the system, like those code changes, they need to happen in a certain way, they need to happen in a certain environment, and they also should be approved by certain people. And auditors are specifically testing these controls so that no one employee is making a change that no one else notices. And I used to perform this test manually back in the day, but it was excruciating to do this manually. But with other advanced technologies that we're seeing, you can build out logic based on, say, the approval matrices and also looking at employee IDs that are making those changes. Look for things like segregation of duties, making sure that different people are doing different steps, etc. That's where the new techniques come into play specifically for change management. And then lastly, saving the best for last is access controls. So here there's a concept called principle of least privilege, which basically means that not everyone needs to have access to everything. And also the access needs to be based specifically on the roles and the job duties at different levels. What I mean by that specifically, for example, is say like a database administrator obviously needs administrative access to the database so that they can make changes, give access as part of their job duties. Then you have, say, an accountant. Accountants need slightly elevated privileges because they need to do things like make journal entries at the end of the month. And then you have auditors. Auditors only need read access to data to perform the testing. I only ever want read access. I don't even want more elevated access to the data because we don't even need it. So, moral of the story, access should be given only to those that need it and at the appropriate level. There's different approaches to take or different groups of employees to test in this for this control. And that's with new hires is the first one. Basically anybody that's onboarded to the company, making sure that the access is appropriate, it's been approved. this is an easy one. Where it gets interesting is when people start transferring roles within a company. Say you've been working at a company for a while, you're in the accounting department, and you just have an itch to become an auditor, right? I've seen it before it happens. So remember that accountants have those elevated privileges, but when they make that transfer into the audit world, they need to have those privileges stepped down or even removed if they don't even need access to those particular data sets. Also with terminations. Now this one's really interesting. Basically, just the control here is that you're testing when a employee leaves a company, the access is removed. That seems logical. However, I see a lot of companies get caught on this control. I've seen people have access up to hundreds of days after they've been terminated, and that opens up your company to a lot of potential security risks for either that employee logging into their account that they had, or even, having somebody else log into that account as well. So making sure that all of the access is only given to the users that need it, and it is turned off when it needs to be turned off. All right, so that brings us to the end of our real world examples. This is ChatGPT's representation of the auditor of the future. I do hope that you enjoyed the walkthroughs, day in the life of the analytics auditor. If you are curious in learning more, I know this was a really, really quick walkthrough, speed run of these examples. A small plug for myself is that I do have 2 LinkedIn Learning courses. One being building a data-driven audit that deeps dives into all of what I covered today. And then I have another one, protecting data for analysis and machine learning, from the security side of how to protect the data that you're using for your projects. All right, so at this time, I thank you so much again for giving me the opportunity to speak with y'all. And if anybody has any questions, I'd be happy to answer them.
Thank you so much, Monica, for the wonderful talk. And we do have a couple of questions. So, audits are essential in other fields like healthcare, compliance, safety, or public programs. What intersection points do you see between financial auditing and these domains? And how do you think AI audit tools might be able to generalize or differ across these domains?
That is a really good question. So the way that these different fields or industries differ is by the level of regulations that you need to adhere to. So the tools themselves that you're using to perform your tests won't necessarily change. The way that you're testing or what you're testing will change. So specifically, like with financial and healthcare, you're going to run into a lot of PII, so that personal information, that when you go about testing it, or especially if you are going to run any machine learning models, you're going to want to do things like anonymize that personal information if you need to be using it for your analysis. So again, the tools still remain the same. You're still going to see the same tools and techniques, but they increase in seriousness or security levels, I suppose, depending on the industry.
Thanks. And we have another question too for you. In the context of state EBT audits, fraud prevention is a persistent challenge. From your perspective, working with AI and financial audits, what strategies or tools do you see as most promising for proactively detecting or preventing fraud in EBT systems, especially given the scale, complexity, and need for equity in these programs?
Yes, that is a great question. So Proactively detecting and preventing is slightly different approaches. When you are detecting and identifying fraud, you can take a approach where you are coming in afterwards to see if any fraud had occurred using that Benford's law. But if you're trying to proactively detect it, you see a lot of these companies building out some models that look at things like historical transactions, where you're located. That way, say you never shop at, say, a particular clothing store and you've only ever, purchased things in your home state, right? If you go outside, if you go on vacation, I remember I would have to call my credit card company and say like, hey, I'm going to go on this vacation. Please don't shut off my credit card, because it would get flagged by those models that they're building. I've seen also the progression of how these models are working, where they won't automatically like shut off your credit card because a lot of people, travel more frequently. But to answer your question, it is all built out that I've seen in these different models that are able to detect this fraudulent, suspicious, or weird behavior that is out of the norm of your typical history with them.
Thanks so much, Monica. And if anyone in the audience has any questions, we encourage you to post them in the chat, and Monica will be here to answer them for you. And with this, I would like to invite our next speaker, Karthika Vijayan, and over to you, Karpagam.
Thank you, Madhura. So Dr. Karthika Vijayan is a solution consultant at Sahaj AI Software. She has been conducting research in the field of conversational AI with voice and text data for almost a decade. Her research has been published in several journals and presented at various international conferences. Prior to joining Sahaj, Dr. Vijayan worked as a research fellow in the Department of Electrical and Computer Engineering at the National University of Singapore. She also worked as research associate in the Department of Electrical Engineering at Indian Institute of Science, Bangalore. She obtained her PhD in speech signal processing from the Department of Electrical Engineering at the Indian Institute of Technology, Hyderabad in 2016. She is an active member of IEEE, ACM, and APSIPA. Off to you, Dr. Vijayan.
Thank you so much, Karthika. It's my pleasure and honor to be here, and thank you so much for this opportunity. Without further ado, let's dive into the topic today. Let me share the screen and see if you can see my screen.
Not yet.
Are you able to share? Oh.
Yes. Cool. Can you see my screen now?
Oh, yes. Yeah, I can see.
Cool. Awesome. So let me start with the presentation. So today, the topic that I'm going to talk about is going to be Agentic AI, the what, the why, and the how, as I would like to call it. So this is as you all might be aware of already, right? It's like the hot topic in the scene of AI in general. So let's quickly go and see what it is and how it is. And I would like to also bring out some challenges. So the flow of the talk today, I have framed it as a quick introduction, dive deep into Agentic AI implementation details, and highlight certain challenges and practical real-world challenges that we would encounter when we deploy Agentic AI in a real-world use case. Cool. Introduction. So where did we start with all this, right? So the entire scene of AI dated back to maybe like even 1800s, where we want our machines to work for us. So this was the first step towards human-computer interaction, where we set up rules for our computers or write codes explicitly in programming languages. Then later, our attention span into bringing intelligence to the machine, like statistical modeling and things like that, where we gave predictive or this little bit of decision making capability to a machine. Machine in this case is definitely a computer. Here, what we let the machine do is let it learn from data a little bit in a statistical sense without being explicitly programmed to do a certain task. Then we dive deeper into modeling, which is basically our humble effort to replicate human brain, right? And we started with a single neuron, mathematical model of a single neuron. Then we dive deeper into multi-layer perceptrons. Then we started with a different kind of neural network architectures, be it CNN, be it LSTM, RNN, etc. And finally, we came into this realm of deep neural network, which made all these AI and all the hype words that you see around AI possible today. In a traditional sense, what was an AI system? It was an intelligent module where we have a model, which is our attempt to emulate human brain. And we started it as of discriminative AI, like classifier models, predictive models, and we had humble models like BERT for language processing, InceptionNet, which is for image processing, and speech based systems like CALD based systems for speech-based processing. All these were our attempts to actually do a effective human-computer interaction. So now we dive deeper into agentic AI, right? So what was a conventional AI system? Just a quick recap. It gave us users access to information, be it the information stored in a database, be it an information stored in some place where we can grab it using a live API call. And these were all targeted towards simple tasks, a predefined workflow. For example, to a conversational assistant, I can ask if it is my employer's conversational assistant, I can ask how many number of leaves do I have now? And imagine I had like 24 leaves capped for an entire year. We had an intent classifier predominantly based on a model like BERT. And this BERT model will identify the intent as, oh, I am querying for leave balance as the intent, right? Now, when it understands, it will trigger a workflow to go and look into a pre-set database where my leaves and all the personal information are stored in from the sense of my employer, and it will grep how many leaves do I have. For example, if it is 21, I have already taken 3 leaves. Now it will go through a natural language generation process where it will write a beautiful message saying you have 21 more leaves left. Now, this is a reactive response, right? I asked for something, it gave me something. And there could be a task-based process also. I want to apply leave on 25th of February. The intent classifier will identify this as apply leave intent. Then it will make an API call to actually write into the database that I want to actually apply for a leave, reduce my leave from 21 to 20 inside the DB, and give me a confirmation message that your leave is successfully applied. So this is a reactive messages. It will trigger a predefined workflow, and the information access or information retrieval from user message, that the message that I type, is being identified by a model. And in this case, it could be a BERT-based model, it could be an XLM-based model, and whatnot. Now coming to the AI agent, right? Here we are not defining a workflow. Here, a large language model is sitting at the centerpiece as a centerpiece for getting information from the user messages and inferring what it is. All those intent detection and everything, it will do by itself. For example, if I say that I want to apply leave for 25th of February, it will understand that message. It will do that intent detection. It will identify the entities 25th of February is when I want to apply the leave for, and the intent is application of leave. And it will have a myriad of tools at its disposal where it will call the adequate required tool, in this case, calling a DB, and getting that information grepped from the database by means of an SQL query, and it will write a beautiful message saying that your leave is successful. Now, if my leave balance were actually small after making that write into the DB, right? It will identify that, hey, you have only so much of leave left. Maybe you have to be a little bit careful about taking more leaves. Proactive response, right? So as opposed to the reactive response in the conventional AI system. So this is where the beauty of AI agent lies. It doesn't have a predefined workflow. We just have to expose all the tools available in our ecosystem to an LLM. And this LLM is going to be an advanced LLM like a GPT-4, GPT-01 kind of a model, which can understand, process, and write the response to the query that the user have asked for. Now, let's go into deeper. Like we are talking about the what of AI agent. So we have already seen this the architecture, right? An LLM is sitting at the end, at the core, and it has access to all the tools, and it will try to find out which tools to call in which sequence required to answer a user's query. So this is a goal-driven architecture rather than a workflow or an intent-driven architecture, as opposed to our conventional AI. Conventional AI, we will have an intent classifier, which will understand the intent. Then it will trigger a workflow. So it's like a workflow-driven or a task-driven architecture, as opposed to an AI agent, which has a goal-driven architecture. And what's the goal? Serve the user queries in whatever manner or task sequence of tasks possible. So it will have a defined objective and strategies. And what is strategy in this case? It has all these tools available to us. Each tool will have its own tool description. Like search internet could be a tool, which essentially means that you have to trigger that tool to actually trigger an internet search. Write SQL query is another tool where the LLM can call that tool, and that tool will write an SQL query associated with a natural language message, wanna apply leave on 25th of February. So these are all the tools available. Based on the tool, it will strategize its own actions. Now the other bit is memory augmentation. We can actually provide a short-term or a long-term, little bit long-term memory to our AI agent. It can choose not to use or choose to use this memory to make sense out of a current user message and club that current user message with the augmented memory together to understand and infer what is the next possible set of actions to be called. Now, finally, it has planning ability also, in the sense that if we are actually calling this AI agent for a scheduling problem, it will actually plan the sequence of workflow that it has to take from this point in time to reach to an end goal, which is basically serving the customer. So these are the core principles behind AI agent. Now let's dive a little bit deeper into the building blocks. So now we have seen what are the core principles. Now the core principles are exactly ported into the layers of the pyramid. Okay. So we know that all the tools that are available in the ecosystem are actually are provided to the LLM, which sits at the core of the AI agent. For example, the generative AI model that is shown here at the base of the pyramid is actually going to be the driver in this case for an AI agent. Now, what does it have access to? Tools. And in this case, tools could be other agents or programmatic flows that we have set the agent to track. Now, on top of that, there is a memory. And then it has a planning capability also. And this flow could be a sequential flow that we can set predefined, or it could be a hierarchical flow, which also we can set, or we can let the driver decide. So now, after all these, we can actually let a graph represent this flow. It could actually be a dynamic flow, hierarchical, sequential, whatever it is. Now, on top of that, there is one layer sitting, which is an orchestration piece, which lets our one agent to communicate with other agents in the entire ecosystem, providing an application. Cool. These are the building blocks. So we have seen what is an AI agent. It is actually it is a proactive AI system which can actually decide its own workflow based on the information given presented in the user's question, as well as augmented memory. And based on the tool description, it can strategize its actions. So this is the what part of the AI agent. Now the why part, I think we all already know. So I only have like one slide to explain the why part of it. As you already have seen, right? It has an autonomous functioning. We don't have to actually preset a workflow and preset the training also based on a data set. It will require only minimum human monitoring. The other bit is it can adapt to unseen data environments, the database-based environments, where it can strategize new actions based on the previously taken actions and the tools that are available to its disposal. So if we think about the applications of AI agents, there are a myriad of applications, right? Self-driving cars, self-navigating drones, personalized assistant for anybody, personalized tutor, personalized banking assistant, conversational assistant, and whatnot. So this is all the kind of applications that an AI agent can perform. So this is the why part of it. So obviously, right? It is as obvious as it is. AI agents are going to be our future, to be very honest. Cool. Now let's like dive a little bit deeper, the how part of it. We have seen the what is an AI agent, why we should go for an AI agent. Now we should see how we should actually implement an AI agent. So there are certain steps or certain tasks that we follow while building an AI agent. For this talk, I have taken an example of a personalized assistant, a case study, where this is a personalized conversational assistant, which can actually serve as a student's helpline assistant or a faculty member's helpline assistant in an organization, in an institution. Okay. So what are the basic steps that we should go through? This is the life cycle of building an AI agent. We have to define the scope and goal of this AI agent. Very importantly, for a personalized conversational assistant, which is bound to a specific task. In this case, in our example, this personal assistant is bound to help the students and faculty members of an institution. So that is its binding, right? So in this case, the AI assistant is supposed to answer certain questions and it is not supposed to answer certain questions. So it has a tight scope. So we have to define what that scope is. Later, based on the scope, we will define an architecture and workflow. And finally, when we are dealing with a multi-agent kind of a system, multiple agents interacting with each other, we should have strong component evaluation for each of the components in the pipeline. Be it an agent, be it a programmatic workflow, doesn't matter. We should have tight evaluations on each of the components in our pipeline. So these are roughly the steps that we should adhere to while building an AI agent. Let's start with the scoping part. So what are the scope in this case, right? What are the things that this AI agent is supposed to do to help the faculty members and students in an institution? It should provide them with information access. Information could be a course syllabus, code of conduct for faculty members, previous year question papers, and whatnot. It should give recommendations on like best practices for teaching, online resources and extra study materials for students, etc., etc. It should help faculty members with certain things like scheduling, how to schedule an elective, making sure that minimum number of students are enrolled to each of the electives and there is a faculty member allocated to each of the elective subject. Or it should actually help the faculty members in scheduling examinations. If there are like 4 years of students, it should be able to schedule exams effectively so that their examinations will get over in the minimum number of days without scheduling conflicts. It should help with actions like the apply leave application that we have already seen. Maybe it should help faculty members apply for a leave. It should help students register for an elective course and whatnot. So these are sort of the scope of the AI agent. And we should also prohibit this AI agent to serve other kind of queries like hack into exam systems, to download this year's question paper. It should actually avoid that kind of things. So the scope is actually tight bar. Now we have defined the scope. We should actually also identify the resources available to serve those scope, right? For example, information access and the actionable part. It should know that there are in-house databases and APIs available, right? APIs to apply for leave, APIs to register a student for a course, databases including faculty's personal information, students' enrollment information and whatnot, in-house text documentations, course syllabuses, previous year question papers, code of conduct, etc. These are all text documentation. Other online resources, which can be supplementary materials to students like, I don't know, Coursera, deeplearning.ai, those kind of things, online resources. So it should actually get access to all these resources to serve the defined scope that we had in the previous slide. Now we will design a multi-agent system. So we have we should have a SQL agent to query the databases. We should have an API agent to write the API call and call the APIs to get relevant information or register an action. We should have an optimizer agent to actually schedule exams, schedule courses, etc., etc. It should have an internet search agent to actually cater to very specific and identified resources of online learning. And finally, on top of everything, it should have an orchestrator agent which will identify where to route a particular query from a user to. So I don't have time to go through each of these agents. So I picked the two of my favorites. So let's start with the SQL agent, because this is something that is talked about all over the place now. So here an LLM should sit at the base, just like that the pyramid that we have seen, right? The base layer is an LLM. And in this case, an LLM should have knowledge to write an SQL query from the natural language message. So if I say I want to apply for leave, or I want to know how many leaves do I have left as a faculty member of this institution, it should convert that to the corresponding SQL query to get the relevant info from the database. And the LLMs in this case could be SQL Coder, Code Llama, Query GPT, etc., which has pre-trained knowledge to write an SQL query from a natural language response. Now it will write the SQL query. There could be multiple other tools at its disposal. There could be a query validator. It will take a database schema and the return query, compare both with each other and say that, this is a valid query. Let's execute the query. If it finds an error, there is something fishy, it doesn't match with the database schema, it will, the LLM can actually call a fixer, SQL query fixer. That's another tool at its disposal. And it will actually fix the query or rewrite the query based on the error message thrown out by the validator tool. So these are some of the tools that are at the disposal of the LLM, which is a query generator or SQL query writer. And together, all of this create an SQL agent. So there is an LLM at the base. There are multiple tools. It doesn't have any memory because it's a one-to-one mapping, because all layers in that pyramid are not necessarily for all agents. And finally, it doesn't have planning ability also, because it doesn't have to plan anything. And finally, it will execute a query and get the relevant data required. So this is a graph that gets this thing done, and this graph is generated using the framework called LangGraph. And graph is a very common representation to represent a workflow for an AI agent. So we will start with getting relevant tables from the database, retrieving the database schema. We can also identify which are the relevant table columns required to just cater to the number of leaves left for a particular faculty member. It will generate an SQL query, validate it, execute it. If the execution fails, it will call a fixer. And finally, it will end the flow with a successfully generated SQL query. So this is an SQL agent. Now, the most important agent is the orchestrator agent, right? So in this case, all layers. So for the orchestrator agent, what is a general norm or what is a general practice that we follow is the pyramid that we have seen. Orchestrator agent would most probably will have all the layers in that pyramid. Whereas an SQL agent may have two layers in that pyramid. An API agent may take 3 layers in that pyramid. So any other agent, it's not necessary that all the layers should be there. But for an orchestrator agent, most probably all the layers are going to be present. So it will start with an LLM. In this case, this LLM is going to be a much advanced LLM. It cannot be an SLM like a 5 model or a 5.2 model. It has to be a bigger LLM, which has that reasoning capability and understanding capability, like a GPT-4 or a GPT-O1, or now even O3 is there, right? And of course, the tools layer are anyway going to be there. In this case, multiple tools are there, which are agents. So the SQL agent is a tool at the disposal to this LLM. API agent is there. If there is internet search is just another tool, it's not an agent. It's a tool that can be triggered. Then it needs access to memory also, context maintenance, right? So a person can ask follow-up question. Context maintenance is a huge issue, as you can imagine till now, right? So it needs access to the previous queries and the previous actions the agent has taken, and most probably the previous response from the agent also, to make sense out of the current query. And then it will have planning abilities. The planning ability can actually be that layer could actually be just another agent, an optimizer agent or a planner agent, or it can be a set of hierarchical or a sequential rules that we write for the planner. It could be either or. And finally, it will actually do that orchestration, and orchestration will have its own graph, like a DAG here, or it could be like a cyclic graph also, depending on if there is a feedback loop or anything. So this is how the orchestrator agent works. It can actually call SQL agent, it can actually call API agent, a combination of API and SQL agent, and finally trigger an internet search also, and whatnot. So as I was saying, right, that LLM that sits in this place, particularly for that planning and orchestration, this could be a React agent. React agent is actually a particular agent which can combine the reasoning and action together. Whereas in our conventional AI systems, what did we do? We did the reasoning first, like intent detection first, then trigger an action, which is like, maybe just call the API. Here, what we are going to do is, we combine the React reasoning part and agentic action part together, and they interact with each other with a single prompt. Okay. So the re part will have a chain of thought kind of prompt where you actually give the way to think, if this kind of question appears, think like this. And then the act part will have instruction prompting and basic rules, as well as few short examples, like do this, do this, do this kind of a thing. So these two prompts sitting together will enable our LLM, that is going to be an orchestrator agent, to reason and act. And this act part could be just tool calling. Okay, so this is the specialty of this particular orchestrator agent, and orchestrator agent usually is going to be React unless it is trained by itself for a specific applications. Now let's actually take a quick look at the workflow. So for example, a student is coming and asking, give me the syllabus for some CS course. So the LLM is now thinking or reasoning, need to fetch syllabus, which is an in-house document. So I should call upon a document rag. Okay. So it will trigger the document rag, which is kind of a tool / an agent. It will have its own feedback loop, what to call, which document to identify. Maybe there is a hierarchy sitting inside this document rag. That's why I'm calling it as an agent. Finally, it will take all the required syllabus URL and pass it back to this LLM, and it will write a response saying that please download the syllabus from this particular URL. Now the student is asking a follow-up question. What was the average mark obtained by my senior batch for this particular course? Right? Now the LLM is thinking, it has access to the previous question and the previous answer and the previous action it has taken. So it knows that the course the user is talking about is CS1001, which is from the previous question. I need to fetch the previous year's mark sheet from in-house DB. Now that is a DB, right? Because the previous year's marks must be in a tabular form. So the SQL agent will write this appropriate SQL query, and you got 45.7 as the average mark from last year 2024 out of 100. Now the LLM is proactive. Okay, so it knows the user query, it knows the previous user query, it knows the previous answer, it has all the information required to answer the current query. So it is saying that you know what? You don't have to target for the 45.7, which is an average mark. The highest mark was 98. That is also in that DB, right? So it has access to that as well. So if you work hard, you can actually score a 98 rather than targeting for a 45. Now, the user is asking, oh, give me course materials. Maybe now the student is motivated to secure a 98 instead of a 45. He or she is asking for more online learning material. So now the LLM knows the previous two questions, previous two answers. So it knows that the user is talking about the same course, CS1001, and it needs to fetch learning materials. So there are some material which are in-house, right? Like previous year question papers, previous lecture notes, etc., which it can fetch through document drag. It can also trigger internet search to look for online course materials and combine them together and give it to the student saying that, hey, some resources are there in the internal URL, in your intranet and whatnot. And there are some other extra learning materials from the internet. Please go study. So this is the proactive response part from the agent, AI agent. So just to conclude, what it can do is it can reason and infer from the current user question, memory of its own, and previous action it has taken. Now, based on all the information that it has crunched from all these multiple sources, it can actually trigger a workflow which is dynamic based on that particular point in time. So I have put an Iron Man model, which is like a smart LLM. It has access to all these tools, which includes like a detective model, which can actually look into DBs, maybe like a I don't know, dart gun model, which can call an API, and multiple others. And Iron Man will get all this information from multiple tools, and it will crunch all this information inside and trigger a final agent with a mic, which can actually read it out to you or sing it out to you or whatever. So it's a dynamic workflow. So this is the AI agent part. Now the last bit, risks and mitigation. Now we have actually, this is all fancy up until now, right? But when we come and hit the real world, that's when, things happen. So when we talk about an AI agent, accuracy is the most important bit. So we need to actually take, if there is an SQL agent, we need an evaluation pipeline for that. If there is an API agent, we need an API evaluation. If there is another agent or programmatic tool like an internet search tool, we should have an evaluation around that. So detailed evaluation frameworks are required to ensure accuracy of each tool piece, whether it is an agent in itself or a programmatic piece. We need accuracy. We need to ensure accuracy around it. The second bit is guardrail, right? As we were talking earlier, if a student wants to hack into the current exam center, we should prohibit that. So malicious requests should not get catered. Malicious hate, other kind of information should not get passed. Also, scope has to be maintained. So, for example, in this case, if the application was around faculty members and students helpline, it should not answer questions about India-Pakistan war, right? It's not meant to do that. So scope is a set scope here. It should only answer questions regarding the syllabus and whatever is in the purview of that institution. So scope and malicious attempts, we need to curtail. Dynamic environment, it should adapt to. And sometimes this adaptation requires fine-tuning. So depending on the criticality of application, one might call for a fine-tuning or not. Ethical considerations, as you can imagine, data privacy, data security, all these things we have to curtail. And bias in the system. There are huge amount of effort from the bigger corporations like Meta, OpenAI, Apple, etc., to curtail hate speech and bias as much as they can. But it is also on us to actually mitigate that bias. And finally, use it only for legal purposes, not like illegal applications. But that's again an onus is on us as a user, right? So finally, I'll conclude. Agentic AI is an AI system capable of dynamic decision making, minimum human monitoring, and it is actually significant for personalized and dynamic systems. Development starts with the goal-driven architecture. It has an LLM at its base and multiple tools at its disposal. And the tool calling, the sequence, and when to call, what to call, this is a dynamic workflow. And finally, we need to set up best practices around the usage of AI system, which includes elaborate evaluation frameworks to span all the components. There should be enough safeguarding and adaptation and ethical considerations need to be set up. Thank you. Thank you for your patient attention.
Thank you, Karthika. It was very insightful into agentic AI, and we do have few questions which are there in the chat. So I'm just going to read it out to you. Is the difference between task-based AI and agentic AI just a matter of chaining tools together or something deeper, like memory and self-direction?
I think I explained that already. It's dynamic, actually. We don't have to. So if we go ahead with a conventional AI system with the same set of tools, it's still, as a designer, the onus is on me to write the predefined workflows in a preset fashion. Whereas in agentic AI, I just have to collate all the tools that are available in an ecosystem to serve certain things within the scope of the design. Then everything from there, the agent will figure it out. So that is the dynamic workflow is the key factor here. And that's a significant difference from conventional AI.
Karthika, how do we know what is the right tools to pick and put together that agent? How do you decide? What is your thought process when you put that together?
Sure. So in our case, what we do is we write like elaborate tool descriptions. So this tool is meant for this purpose, and there are scopes and limitations around it. And it will repeat for every tool in our at the disposal. Now, when a query comes, the LLM knows what each tool is capable of, and if there is a sequential dependency between a tool. For example, if a faculty member is asking for leave, that faculty member has to be identified identified ahead of time, right? So maybe it will look into the login information or make an API call to the system to pick the unique ID of that faculty member. Everything should come after that. So there is a sequential dependency. So it should actually trigger the API agent first to get the unique ID of the faculty member, then go into the database to write the correct SQL query and grab that particular faculty member's info. So there is a chaining or a dependency between the agent itself will figure out as and when it goes. So the workflow is dynamic in that sense. This is possible with conventional AI also, but then as a designer, it is on us to say that, oh, you should actually call this tool first. And there is a hierarchical or a graph-based dependency between these tools.
Thank you so much, Karthika. There are a few more questions if you want to just answer them in the chat.
Sure. Yeah, I'll take a look. Yeah, thank you. We have a time limitation. Yeah.
Thank you.
Cool. Thank you, Karthika. Yeah.
After our next speaker, Aaron is a seasoned startup founder and CTO with more than 15 years of experience spanning enterprise SaaS, consumer mobile, infrastructure, and health data privacy project. He recently concluded 5 years with Evernow, a leading telemedicine company focused on women's health and aging. While there, he led data efforts resulting in published research furthering our understanding of race, ethnicity, and socioeconomic indicators and how they impact menopause symptoms. Off to Aaron.
Oh, thank you. Thanks for having me, WIDS, and also Karthika, who I get to work with in my current role, which is a lot of fun. I'm probably an outlier in this presentation series in the sense that I'm not a woman and I'm not a data scientist. But I feel like I've had the last 5 years of my life really shaped by the intersection of those two things. And to trying to make meaning out of my work. And so let me start my slides here. Just 1 second. Okay, you can see that, I assume.
Yes.
So former co-founder and CTO of Evernow. Evernow started about 6 years ago. It's one of the leading menopause telemedicine companies in the United States. Lest you think that this presentation is going to be a shill for that company, I should mention that MIDI is a great company, Alloy is a great company, Winona. There are a whole lot of companies that have sort of stepped in to fill this care gap. We were one of them. I'm really proud of the work that we did, but I also think that this was a sort of a rising tide situation for the quality of care of women as they age, and that we were one of many participants in that ecosystem. Like Karthika mentioned, I have no effective medical background. My career has been more shaped by curiosity, I think, than anything else. And that curiosity led me first to health data privacy, where I did some experimentation. And then at the sort of juncture for when I was trying to figure out what I wanted to do next, I think I was challenged to align my work efforts to things that were aligned to my values. And I looked at this, and this was circa 2019. And this one really caught my eye. Dr. Alicia Jackson is the CEO and co-founder of the company. This has been a passion project for her for a very long time. And I think the idea that I could build technology in that sort of aligned to my values seemed like a great objective. What do we know about menopause? We don't know a lot. When I first started this company, I called my grandmother. And my grandmother is now 90 years old, and this was perhaps the most awkward conversation I've ever had with anyone. But it was illuminating, because I think there are cultural taboos that exist, and I would like to think that over the last 10 years in the United States, we've gotten more comfortable talking about these topics in the same way that we've gotten more comfortable, I think, in aggregate, talking about women's health in public in general. But these taboos still persist. And you can feel these taboos on generational boundaries as well. And so, someone who's 90 years old, a product of the Great Depression, this was a very private thing for her, and I don't think she wanted to talk about it to anybody. She was kind enough to humor me in my questions, but it's not just sort of taboo. We don't have research around this topic. Humans and some toothed whales are the only species that go through menopause. And you would think that we would spend more effort on this. But I think our limited funding and research compared to lots of other topics is indicative of lots of things about sort of problems in society that persist. I think another aspect is, though it affects just slightly more than half of us, you're not going to die from menopause, at least not directly, right? And so if you are an insurance company, this is something that you are less incentivized to really care about. And finally, of course, this sort of translates into a historic neglect for women's health issues and research. I mean, I think this is sort of a thing that goes without saying, but we've done plenty of meaningful studies that we cite in regular, scientific parlance, but they may have not had any women in them, or they've had a very subset. And you can feel this on other axes too. Race and demographics, socioeconomic status tend to color the way that scientific research tells us things, and we treat these things as fact, but they may not be grounded in full reality. This gap, the gap in knowledge, I think, has translated to this, what I call the pain industrial complex. I'm sure other people have called it this too. I have this book here. This is Feminine Forever. This is the cover here. This was a 1962 first printing. Disappears into my camera. This book posited that if you would just take hormone therapy, your husband won't leave you. This is a product of 1962. It is exactly what it sounds like, right? And this book really changed American society about how we thought about interventions for perimenopause and menopause. This book and the research behind it was sponsored by the industry organization that produced equine-derived estrogens. And this book was essentially a mechanism to sell equine-derived estrogens. And it worked. It was really, I mean, if you look at sales data for estrogen in the 1960s as an intervention, you find that it spikes. The problem, of course, was that this book did not talk about the side effect of taking estrogen without progesterones, which is you end up with uterine tissue buildup, which can straight line translate into cervical cancers. And this, or uterine cancers, this book was very effective in the sense that it raised the idea that there may be meaningful hormone-based treatments that you could use to treat menopause, but it also introduced an entire generation of women to cancer. And so you can understand that this left an entire just sort of scar tissue in society as we think about how you might do this, how you might treat this condition. In 2002, the Women's Health Initiative was $1 billion plus study that was looking at the effectiveness of hormone therapy. And in 2002, they called the study before the research was fully complete. And the lead researcher in charge stated in public to the New England Journal of Medicine that hormone therapy invariably causes cancers and we shouldn't prescribe it. And this was the news. If you or your doctor or your mother or whoever, somebody in your life knew this because it was huge news. And you can look at the sales of hormone therapy in 2001 versus 2002, 2003, 2004, and you see a precipitous drop. You understand it. And each one of these things, your gynecologist was in grad school during the one or the other of these probably. And you learn something and you're unlikely to question it after it's been put into your head because it sounded so authoritative. The reality is that because there's so little money to be made from an insurance payout perspective, gynecologists are unlikely to maintain a knowledge of the current subject matter unless they sort of have a specific reason to. And as a result, these things, the WHI study turned out to be studying primarily women who are postmenopausal, primarily with other conditions, including that majority of them were smokers. And so the data was valuable, but the interpretation was off. But this gap of knowledge meant that people who might have had, very sensible care plans put together by licensed medical folks didn't. And this gap, I think, is in turn filled by grift. There's an entire industry of selling women stuff because they can't find good medical care, and the stuff has no responsibility to be effective. There's no way to measure it. The U.S. medical system allows supplements that basically do nothing. And there's actually some really interesting research on some herbal Chinese medicine that does probably work, but we've also made it very difficult to bring in things that might work outside of sort of medical industry norms. And so this sort of all perpetuates this weird space that we're stuck inside. This is one of my favorite things I've ever seen in real world. This is not a GPT generated image. Somebody in the mission, circa 2019, was tagging power boxes with this menopause themed graffiti, and I think when I started, I thought like, oh, well, if you're having these issues, you should go talk to your doctor. You should, there has to be a scientific path for this, like there are plenty of other scientific paths. But as I got to understand the problem space more, this became more understandable to me. Like, I think there is this, there's a latent rage in the system. And I think if I were in the shoes of somebody going through this, I might have that same feeling. And I don't know if I would tag a signpost or something, but I understand the energy behind it. So when we founded EverNow in 2019, the thought was that we wanted to bring high quality evidence back to care, particularly in places that menopause expertise is hard to find. Like if you're in the Bay Area, if you're in New York, if you're in a major metropolitan area, even circa 2019, the odds of finding good care was reasonably good. You may be able to find it, you may not be able to get an appointment, but you could, at least there were experts. I think one of the things I'm proud of is that I think EverNow participated in a rising tide situation where we talk about this more. And as a result, the national interest around this topic has meant that there are more providers and the care quality has gone up. And when I talk about the competitors that we had, I'm not sure that there's a meaningful care quality differentiator because I think they're hiring quality clinicians who are doing great work and, the best available medical interventions based off of contemporary policies. EverNow though, so Alicia Jackson, the CEO, is a scientist first. And so she thought that, the objective here should be to build participatory science as a side effect of this, right? So what can we do to collect additional data that we can both improve the patient's life, but also then help us understand these conditions more. This sort of speaks, you can't improve what you don't measure. And this starts with on your own interventions. Menopause care is primarily symptom management, right? And so a core part of that is understanding how you feel today, how you feel tomorrow, and it's low. I would say it's low detail, high frequency data that helps you understand these things, because hormones fluctuate enough that a one-time test really isn't going to tell you very much. So when we built this, though, we didn't set out to build data science, and I say that with capital letters in the beginning of it. What we tried to do is solve some initial business problems. So when you go to a new doctor, you're going to go fill out some paper forms or maybe something online if you're lucky. And we had to do the same thing. And in our specific case, menopause care online is an interesting one. It sounds risky from like a medical risk perspective. It's actually very not risky inside some very specific safety bounds. And so our objective with our intake pipeline was to find people who were outliers from what we considered medically safe to treat from a telemedicine perspective, and to redirect them towards brick and mortar, more traditional doctor's offices. So we built essentially a full medical intake before you became a patient of ours, so that we could make sure that we were, identifying people that we could have a successful outcome from. And so our goal was not to build perfect, clean data or a research laboratory based, a data design driven approach, but rather we needed to solve some practical business problems to start. The women's health universe has sort of centered around this menopause rating scale. It came out of the research in the 70s. So there are 11 specific questions that are rated on a 0 through 4 scale. This has primarily been used in research laboratories. It's infrequently used in the practice of medicine, I think, because it has sort of a very clinical feel to it. And if you were having a conversation with your doctor, this may not be the way that you express your experiences. I had some questions about this. What is a 3? These are ungrounded numbers that we use to measure a scale. And there's actually been a meaningful meta study about the use of the MRS, and it turns out that women may not your 3 may be somebody else's 2, but you will consistently rate the same level of severity over time. And so this data set has value in sort of a relative sense, even if the absolutes don't have meaning in and of themselves. It's best used as pre-post treatment impact assessment, so that we can understand, how are you feeling today? And after we've done this intervention, how are you feeling now? And is this better? And again, because menopause care is primarily symptomatic in its nature, or symptomatic care in its nature, having tools like this are really essential. So we built this into Evernow as a core building block. We extended the questions by a few additional ones, but the goal was to get repeated interactions and understand whether we're doing our job and whether you're feeling better. We didn't set out to build a large data set, but we accidentally built the largest data set that we are aware of in the world on this topic. And in part, that's because we had a funnel. If you think about a direct to consumer business, we had a funnel that was driving traffic to our website, and people were interacting with our systems. And because we were collecting this data before you were fully a member, we had a very large data set that just accrued in our system. I think we're well north of 250,000 people who have gone through at this point. In addition to specific medical questions, we also asked demographic data and comorbidities, things that, other conditions that you have. So we have a lot of very rich data in poorly structured form, but a lot of very rich data to work with. Because we had that scale, we also were able to, we have data that's statistically significant about historically under cared for, under researched, under understood population groups, which we'll get into. But this is, I think, really exciting, is to shed some light on people's experiences using large scale data. And because we had this before our conversion funnel for a long period of time, this grew faster than our customer base. The company has since shifted its approach, but this data set remains very valuable. It's a great data set in a lot of ways. but it is a purpose-built business database, right? And so we had a lot of work that we needed to do in order to translate it into something that could pass, the scrutiny of science. And the scrutiny of science is very different than the scrutiny of, what your VP is asking you for, to tell a story about, what's going to go in the next growth slide. And so this to me was a real learning experience. It's like, how do you validate this data? How do you create confidence that could pass a medical review board? All of this was a lot of work. The MRS in particular, a very highly powerful tool in our arsenal, but some of our patients only answered that once, and some of the patients answered it every day for a year and a half or 2 years, right? And so we have a really broad variety of data frequency, interaction frequency in this, and we needed to create a structured way to normalize these things so that we could compare apples to apples on, like, what does a 3-month trajectory of a patient in our system look like, and what does a 6-month look like, and how do we track that relative to specific medical interventions. Obviously, meaningful de-identification here. We are a HIPAA-covered entity. So we have our own data governance questions. But before we're handing data off to a research organization, we have additional responsibilities to make sure that this is properly de-identified beyond just the, the 9 forms of PHI, but into intersectional data that could be used to reverse engineer locations that very small people groups might be in. So the de-identification was a significant amount of work for us. We are not scientists, but the Buck Institute is scientists. And Jennifer Garrison is a friend of mine, Dr. Jennifer Garrison at the Buck Institute, just north of San Francisco. The Buck Institute is a privately funded research institute. The Garrison Lab is focused on women's health, uterine health, and aging. She is incredible, and I highly recommend that you follow along for the things that she and her team are putting together. She's one of the most inspiring people I know. And it was a real honor to get to collaborate with her on this. Her team was exceptional. Alison Kirkberger there. And this process involved coming to a clean interchange format that we could agree on so that as we're taking data from our system, that they would then have an input format that we could iteratively work to get to research output. They were working primarily in R, and our interchange format was very, very wide CSV files. The technical journey, really quick. This is a multi-stage ETL to get to that end product. And we did it, again, in a very iterative form. So we had a standing interaction between our Postgres databases that run our core service via Fivetran. It's a SaaS provider for doing ETL. And then we have a privately hosted DBC instance that we were using to normalize that data to restructure it in ways that made it more suitable as sort of the input for truly hairy BigQuery queries that we use to slowly over time develop the final result. But this pipeline worked really well for us. I think being able to experiment with your data and data shape before you're committed to that final output was really helpful. And BigQuery, even in its relatively mundane collaboration tools, was very helpful in this process. The other thing I'll note is that we wanted to make a clear firewall between our private data and what our researchers were delivering. And so having clear governance and some external visibility on how we did that, again, helped us to cross this chasm of research respectability without bending the rules. And I think that was really important for us. So we wanted to do this the correct way. For this to be considered valid science, there's a protocol that you really need to follow. So what did we learn? There's an existing study of I think there were 700 or 800 data points in it that suggested that symptoms vary. Menopausal symptoms vary by race and ethnicity. We in our study ended up with, I think, 48,000 data points that we used. So we have not quite an order of magnitude more, but we're heading in that direction. I guess it is a bit more, but with a much larger data set. And our first job was to to figure out like are the results that we're delivering in alignment with the existing research, right? And so we have a lot more that we want to talk about coming out of our data set, but our first objective was to benchmark it relative to published papers in the past. And so we focused on race and ethnicity because there's enough research on this topic that it would give us a good handle on like, is our data aligned? So what we found is that symptoms do vary by race and ethnicity in ways that are in line with previous studies. Because we have a much larger population pool, we were able to have some observations about people groups that have historically been underrepresented in these studies. And so we have some, we'll say, new data relative to what's been published before on race and ethnicity. The other thing that we have found, and should be sort of intuitively obvious, is that low socioeconomic status corresponds with worse symptoms. And you can, I think that on race and ethnicity, there are hypotheses that can explain some aspects of this, ranging from diet to sort of cultural behaviors. And socioeconomic status, you can imagine that there are hypotheses as to why these may be true. Just in sort of environmental stress, there are lots of reasons that you can come up with without thinking very hard. But our research also showed that these are independent variables, that they don't one, being one or the other, the intersection is what's driving this. It is not one thing. I think we got to the other side of this, and though we were focused very much just on this race and ethnicity question, the thing that I sort of took away from that is that we did this research and I have more questions. And I think that that's really exciting. I think that participating in science around this is that's the fun part. And if you think that you are solving the problem, you probably didn't understand the assignment. But we learned a ton. This paper was published in the Journal of the North American Menopause Society. We have a couple other papers that are in the pipeline, but this process took far longer than a product-oriented software engineer am used to working in. And that is in part because of the validation required to do it, the peer review required to get it published. It is a complex process. But I'm really proud of the work that we did here. And I think that there are opportunities that all of us can find in our day jobs. And I think this is sort of my challenge at the end of this, is that we didn't set out to build this data set. I was lucky enough to work on a problem space that I care a lot about. And so I think that it helped me to find drive in this, but we were solving a real problem. We weren't just doing clinical research or something. And the value for this work is that ultimately we're feeding this information back into how our providers treat our patients and can be informed about the issues that might affect their experiences going through this time in their lives. So I guess this is the challenge at the end, which is to find problem spaces that are meaningful and personal to you. And I think that I don't know how much energy I would have put into this if it wasn't something I was deeply curious and it was a personal thing. Like most people have a mother, and so I am familiar with the second order effect of this. And I think looking for opportunities in data that while you're solving a business problem can create even more value. And we definitely got that out of this process. So thanks for your time. This was I found another menopause graffiti in San Francisco at the same time. But thanks for your time. Thanks for having me. And look forward to hearing any questions.
Thank you so much, Aaron. I want to reiterate what Nishan has said in the chat. I want to take that moment to recognize and appreciate that your work, you have worked in the space of women's health and menopause, where male leadership is still relatively rare. Your willingness to engage deeply and thoughtfully in this space shows your strong allyship and commitment to inclusive innovation. And thank you for being a speaker here. And
Sure. Here's what I have a counterpoint to that, which is I think that this should be normal. Yeah. I think that for society to move forward, this shouldn't I feel privileged, and I have the outside appearance of privilege, right? And if I'm not using these things to do something towards these ends, what are we doing here? This is not a women's issue. This is a societal issue. This is a human issue. So yeah, I appreciate being a man in menopause, and there are very few of us. I think that we have a lot more to do culturally.
Yes, definitely. There are more things to be done there. There are a bunch of questions, and we still have some time. And these are from Nishran. How do we build credible evidence-based solution in the environment, and what will it take for insurer and broader healthcare ecosystem to take menopause seriously as a priority?
I think that is a very hard question. I've walked away from this bit. I left this company last year. I'm still actively involved in as advisor. I think these are very hard businesses to build because insurance companies don't take them seriously, and so the payouts aren't significant. I think there are challenges because let's be transparent. One of the primary early symptoms of perimenopause and menopause is brain fog, and that can have impact on your work. And so I think that there are very reasonable reasons why you wouldn't want to disclose that to an employer or to there like our as an employment-based insurance system that we are living with here. This is a very difficult challenge. I think we need to do more to quantify the costs because I think that insurance companies are probably paying out for menopause care in secondary ways that they do not directly observe. I think the number one killer of women in the United States is not breast cancer; it's heart disease. There is meaningful data that is not fully. This is where Jennifer Garrison and her team are the right people to listen to, and not me. But there's meaningful data to suggest strong correlation between decline in estrogen in your body and upticks in heart issues and mental conditions. And I think that there are ways, if we want to think about overall longevity and increasing, like from a financial perspective, you are a quant at an insurance company. The quantified way to think about this is to reduce the payouts for heart disease and to extend human living. So that premiums, like there's a mathematical solution to this, but it may be an indirect one. It may not be by providing directly menopause care that you are solving for X. But maybe that's the way that it should be. Like I have some real concern about companies that were in our space that were, focused on employee benefits around this topic, because I think there are real privacy risks that I'm not sure I'm comfortable with as both either an employer or somebody who knows women who are employed. Like I'm just not sure it's a good trade.
There are a bunch of questions as well. Is this data publicly available or a subset of it?
Yeah, so the data, so we have a public thing, evernow.com/study has a sort of, this is several years old at this point, but this was not the peer-reviewed research, but rather some of the data that we pulled out. I can provide a link to the PubMed article that I set the screenshot to. That's probably the most authoritative, actually scientific output from this process.
Mm-hmm. Is there an app that collects the data?
This was built into the Evernow patient experience. I think there are a couple different ones. Sort of getting back to the environment that we're in, I think there are interesting sort of cultural, societal, political questions to be asked about anything that is collecting women's health data. That could be subpoenaed. You could imagine building a spreadsheet and probably solving a similar problem. If you wanted to do this at home, the take-home exercise is not very complicated. And I think that the future is probably meaningfully informed. This feels like space for AI innovation around providing meaningful, transformative experiences. That are private and specific to you.
So if I were to talk to my mom and I have to give her an advice on how to take care of her from me, or how she should take care of her, like what would be the advice I should give her?
That is a good question. I think the Nordic states are really far in advance of how U.S. healthcare is right now on this topic. I think that their sort of social structure is just a little bit better aligned to that. And so I think you can find things that escape the sort of cultural war bubbles that exist on this topic by looking at some of the things that are coming out of there. I think the best research today says that outside of some very specific comorbidities that can be really risky. You know, I don't think that hormone therapy is for everyone by any stretch of the imagination, but for the majority of women, it is highly effective, and it is the best thing that you can be doing. I'm not sorry, I sound like I'm evangelizing. I've just been doing this for 5 years. You know, there are meaningful things, but you have to get comfortable with that. And I think that this sort of gets back to the thing I said at the beginning, which is I understand why people are deeply hesitant around these topics. Like, why would you trust science? Like, it has screwed you over repeatedly. Like, I'm empathetic to that in ways that I wasn't before, but I think you have to maintain an open mind. I think you have to find data sources that are outside of, somebody who's shouting at you on Instagram or TikTok or something. Mary Claire Haver is a great author if you want to read her book. There are a couple others that are doing some contemporary work that I think are worthwhile.
Thank you so much, Aaron. Thank you for taking your time to do this presentation. Thank you so much. Off to you, Jasmine.
Thanks, Karthika. Our next speaker is Kasia. Kasia is a data science tech lead at Square, where she collaborates with her team to drive data-informed decision-making. Her expertise spans various domains, including identity verification, sales analytics, e-commerce, and infrastructure. Prior to her current role, she gained valuable experience working at Medium and 5 Stars. In these positions, Kasia conducted numerous A/B tests to facilitate informed product decisions and actively contributed to company-wide A/B testing initiatives. So in her free time, she indulges in her passions for travel, scuba diving, and reading. Now I'll hand it off to Kasia and she can start.
Hi, thank you for having me. Let me just share my screen. Okay. Slideshow. Okay, cool. So, hi everyone. I'm Kasia. I'm going to talk about building data-driven cultures that drive an insight. I just noted I have a wrong date here. I was doing that talk the other day as well, so apologies for that. So, what am I going to go through? So, I'm going to go through 4 different points. First, we're going to define data culture. And then we'll talk about 3 points on how to drive this. So first, that would be via collaboration with data science, and I'll dive deeper into how to build strong partnerships with different teams. Then I will talk about data-driven processes, how to embed metrics into decision-making. And finally, I will talk about enablement and empowerment. So how to scale access to data in an insight. So first, let's kick off with defining data culture and what it is. Also all of my images are generated by ChatGPT. So fun side note. So for me, data culture means decision making. So using data to make decisions, not just going off of a gut, but using metrics, using A/B testing, things like that to drive decisions that a company makes, the decisions that stakeholders make, decisions that product makes. The next one is data literacy. So being able to actually understand those numbers and interpret them correctly and act on them correctly, not kind of try to fudge numbers or make things up or anything like that. And the last one is investment in data, whether that be data scientists, data analysts, and headcount or tooling for the company and for data folks and stakeholders, and just really believing in the fact that data can be helpful. Obviously, there is a lot of other meanings that we can discuss here. This is what I will stop at and move on to the next part as we have a limited time. So first, collaborating with data science, how to build strong partnerships across teams. That's a really important part of building data culture. So here, how to work with data science. So one of the things that I discovered in my career, and it doesn't matter whether that was, when I was a year into my career or whether that was 7 years into my career, there are always teams that are new to working with data science. There's always stakeholders that are new to working with data science and they don't know how to partner. Someone may come from a small startup when there was no headcount, someone might have been on a team that just didn't have a data science partnership. So they may just be a little bit confused and lost as to what we do and how we work. So in my most recent role, I've defined and shared some clear collaboration guidelines on how we want to work together. That includes things like, don't come to me just asking for a number of, for example, how many users clicked on a particular item. Talk to me about strategy, what you're trying to do. What's the question behind the question? Things like that. Make sure that you're involved early and often. There are really a lot of guidelines around what we do and how to best partner with us so we can be proactive. And you can do that and do a walkthrough presentation or do an onboarding document. I actually have both. You don't always need that. But we've done a presentation for the team just explaining what it is that we do day to day, as people are often curious, and that is a great segue to how to partner with us. And then I have a living doc that I often share with people who are new to partnership with data science, new to the company, new to the team on how we want to work together. You might also want to outline, are you the kind of team that is just going to take tickets from stakeholders? How often do you drive your own initiatives versus how reactive you are? Things like that. All that can be covered there. You can host regular things, for example, one-on-ones with your product managers, engineering managers, designers, whoever it is that you work closely with or want to work closely with. Or you can have office hours where people would sign up and just come into the meeting room or hop on a call, depending on whether you're a remote or in person, and can ask their data questions. I have a blog post coming soon with a little more detail of like the guidelines around how to work with data science and how we've used them. So be sure to check that out if you want to pretty much copy paste the guidelines we've created. Next one. So I, for a long time, have believed in driving things bottoms up and just doing kind of a grassroots effort wherever you work to convince your stakeholders to be more data-driven. However, over the past 2 years, I've really discovered a really bigger value of working with leaderships. Whether that's your head of product, head of engineering, maybe you're at a small startup and you want to talk to the CEO or the folks from the C-suite. For leadership can really help you out here. So first, it's important to align on the value of being data-driven. So sometimes that may mean that you need to show your value to those leadership stakeholders, or they may already be bought in. This kind of support from the top down can really help you with your efforts with the bottoms up. If you're working with a stakeholder and you're trying to drive more data culture and their boss also tells them to be more data driven, that makes your life a lot easier. You can position here data as a tool for strategic decision making. You can really present how you can help the teams. And yeah, it's important to build trust with those product engineering leaders, design leaders, whatever leaders you work with closely or may want to work with. And it really helps to make them both your champions and your collaborators. So once I've got some buy-in from leadership on data culture, I actually have flagged a number of like data issues to them, and they help me find folks that would then work with me on those issues. Next one, product and data reviews, business reviews, monthly reviews, operational reviews. Those are only some of the top names that I can come up with. This process may be called something else at your company or may not exist. But if it does, it's really worthwhile joining. So join any sort of reviews that happen on a regular basis. And not just join and listen, although that is important. And it's very valuable knowing what's on the roadmap, what people are doing and what people are struggling with. So you can see how to help them with data. But this is also a great forum for you to present key metrics, any sort of performance trends, discuss what's been going on, and explain some things that folks may be wondering about. You can highlight any sort of improvements that have happened, any A/B test results that you might have analyzed and collaborated with other folks on. And this is a really great forum to showcase any sort of impactful data collaboration with other stakeholders. This is also a really good opportunity for you to help translate data into action for stakeholders. So for example, a metric is up or down. You may want to explain that there is one source of new users that's dying down a little, and that can spark a discussion and brainstorming session with stakeholders on what to do next. Okay, now I'll talk a little bit more about data-driven processes. So I found it's really useful to include metrics everywhere. Here specifically, I am referring to PRDs, so product requirement documents, and EDDs, which are engineering design documents, at least at my company. Now, those documents will be called something else at different companies, but often your company may have a template for how they want things to be planned out by product, by engineering. And I found it very useful to make sure that every PRD or product includes a metric section. So really getting people to think about what are the top metrics that we're trying to move with something. For ADDs, metrics are also useful, but really that's where logging plans come in. So really helping you get better and higher quality data, making sure that engineers think about it. It's not uncommon, whether I've worked at a big company or a startup, that data is a bit of an afterthought for engineers. So that means that they won't necessarily implement the logging that you need from the get-go. Having those logging plans kind of puts it at the forefront and makes it more likely that it will be implemented. So it's important that, of course, you review all of that for clarity, consistency, visibility. Sometimes people want to measure things that are really hard to measure, or you may just not have the right logging right now. If they want to measure something that you don't have the logging for, this is a great opportunity for them to also advocate to get that logging added. And while I started off with being an owner for these sections, I wanted to shift ownership to stakeholders over time. A, that just makes my life easier, but B, at some point, people kind of pick up on the patterns that you're working with, on the metrics that you're usually trying to shift on what could change, and that makes them data-driven. That makes the team more data-driven. It also helps to normalize thinking about data from the start of the project, not kind of as an afterthought. Next one, so being proactive and sharing insights. You should be owning your metrics, you should be exploring them, and you should be looking at trends ahead of requests. So ideally, you wouldn't have a product manager coming to you and be like, hey, what's been happening over the past 2 weeks? This metric is down. It's great if they are reviewing the metrics. It's great if they are asking questions, but you want to be proactive and you want to really share that ahead of time. So instead of having a PM come to you and ask that question, you should be already sharing what you have found on slide 10. If you don't know what is going or why something is going on, you can just say that, hey, I have noticed that XYZ metric is down, or we're seeing this trend. I'm looking into it. I will have an update at the end of the day or whenever you think you want to provide an update. And the next update can be just, hey, we're still looking into things. But it's important for stakeholders to know you are kind of on it. Another one is just making sure you surface those meaningful insights before anyone else asks for them, not just in terms of metrics, but in terms of anything else that's is happening with the product or with parts of the product that you personally may be interested in. Where I think the data science superpower happens is where you can propose data-driven ideas and projects without product thinking about this, whether that might be a tool that you think may be useful for your stakeholders, whether it's something you want to dive deeper into because you had worked in a part of product and you know that there was like a neglected area that you may want to drive. It's really great to do that. That's one thing that you can do and then have stakeholders be bought into making changes into something. Then another one is just looking ahead to what the upcoming launches are, what are the current technologies, what's on the roadmap. So again, instead of waiting for a product manager to come to you and be like, hey, like I need this data because this is what I'm interested in, you could do a deeper dive. You could do an interesting model or anything like that before that happens and make recommendations or even build something. And nobody really cares if you're doing these findings if you don't share them. So make sure you share them broadly. Post them in Slack. Put them in an email. Add them to reviews. So we talk already about like the business or product reviews. All of those places are great. You just need to figure out what works for your company and where people tend to post things. I have had a broad stakeholders channel. I've had specific data Slack channels for us to share those insights. So you can really figure out what's going to work best for you. Okay, next part. Enablement and empowerment. So I find it really helpful to empower stakeholders with documentation and AI. One kind of feeds into the other. So for my team, we have a big document and we've been working on it for the past 2 years. It's a live document. It just keep on adding things or occasionally editing, where we talk about metric definition. We're linking out relevant dashboards and it's the past analysis that makes it really easy for stakeholders to find them. A/B testing analysis, ETLs even for other teams, linking out to relevant documentation, the tooling that we use. I'm a big company. I'm at a big company where you need permissions to access certain data. So I link out to which permissions you need to access our data. And at the end, we provide sample queries. And they have a little note saying like, hey, this is a sample query to look at users over this period of time. And it has commented out some potential filters people might be interested in, for example, for a timestamp, product type, anything like that, that stakeholders can then reuse and tweak, even if their SQL is not very strong. So here, thinking about mostly non-technical stakeholders. This makes it really easy to transfer knowledge whenever someone leaves or moves on. It makes it really easy to have other teams self-serve, and it makes it really easy for product engineering, other teams to just go and explore what prior art you have on the things they may be interested in. I've also used those documents to train AI for automated QA in the Slack channel, which there's times when it works really great and someone asks a pretty simple question that we already answered, and I don't need to do that. I don't need to do the answering. There are times when I am still feeding my answers to the document and to AI to keep on answering for people in the future. But it definitely reduces the amount of time that I need to spend answering some potentially repetitive or simple questions. And it really reduces bottlenecks and helps to scale access to insights, which helps us be more data-driven. Another one is an all hands to showcase data. So really having, again, a data section part of it to make sure that we show what we've done or what we've learned. So any sort of data sections in team-wide meetings are great, or company-wide meetings too. You can present any sort of recent projects, dashboard metrics. I've played around with it myself. So there's been times when I would present projects. There's been times where we just talk about how metrics have moved. Often afterwards, we'll look for feedback from stakeholders and what they want can change over time. What they want may also vary over time. At a recent review, I actually have just talked through the metrics and how we define them and how we think about metrics. So really taking 5 steps back and doing something that as a data scientist to me seemed a little basic. But actually, I received a lot of positive feedback from folks who now really were understanding how what we do helps to generate revenue for the company and helps our customer. Another time, I have talked people through a dashboard, and I also talked them through how to use that dashboard to self-serve. So kind of doing a bit of insights and a bit of here's the filters, here's what you can dive deeper into. Often that can spark curiosity about like data tools, workflows, I have had people ask for specific demos. So they would hear me mention that I'm using a specific tool for analysis. And they would be like, hey, can you give me a demo? Or, we all want to use the dashboard that you guys built, and we want to be able to self-serve. How do we do that? Or how do we run our own queries? Where do we find our data? Anything like that. So often those demos were helpful for engineers. Alternatively, you can just do it during a brown bag and just go deeper on a specific topic with either interested teams, interested stakeholders, other data scientists from other teams, or engineers. So thank you. Here is a link to my website where you can find me. And I saw that there were some questions in the chat.
Yep. Thank you, Kasia. It was really great learning about different practices that you shared to create a data-driven culture. We have a couple of questions in chat. So the first one's from me. I was wondering if you could share an example of a clear collaboration guideline that was particularly effective or helpful.
Yeah, I will be sharing that in a blog post I'm waiting to get approved and go live, but that literally has word for word the instructions and guidelines that I have created with a teammate. But one of the things that was pretty much a game changer for us was, hey, we all want you to come with strategy questions, not with just data questions, and we want to bring some things together.
Cool. Thank you. And then our next question is from Nishrin. How do you strike the right balance between democratizing data access and ensuring data literacy to avoid misuse or misinterpretation?
Yeah, that's a really, really great question. I think it's almost more of an art than a science. It really depends on the stakeholders you have. So I have a what I think is a useful example is usually I create dashboards for A/B testing, whether it's using a tool like Growthbook or even putting that on Looker or Tableau. I believe in making sure that we're transparent about the results. In all of my roles, I have done a lot of education around what was going on. That's all good and nice that we're transparent and people are asking questions and all of that. However, there's been times when that transparency has been misused. We've had, particularly a really long time ago at one of our previous companies, we had a PM that constantly kept on trying to make decisions, with very small sample sizes. As the experiment was running, was trying to shut things down. We've done a lot of education, both one-on-one and brown bags with him, and we ended up just deciding that until results are statistically significant while they are running, we're not publishing them for people to see. So it's kind of a constant battle and a work in progress to make sure that people understand things, that you're doing education, that you have trust with your stakeholders, so that if you share feedback about something or you share feedback about how they are using something, how they are using data, they will listen to you and not just ignore you or just still do their own thing.
That makes a lot of sense. And then the last question we have for you is, what are the key ingredients needed to truly build a data-driven culture, not just using dashboards, but embedding data into daily decisions?
Yeah, I mean, I've done things like brainstorming sessions with stakeholders. One is education, just to make sure that stakeholders understand data and can use it correctly. Second one was just making sure that people are involved. And third one, I would say just like never shutting up about data. To be quite blunt, I find myself often plugging myself into things and be like, hey, there was like an opportunity to use data here, or this is how we could leverage data, or here's how data science could be involved. And that means that then people can think of more use cases because they've had some examples and hopefully are more inspired. But they also know that I probably will want to be involved in what is happening and what they're doing.
Kasia, just a follow-up question over here is that how much should we weigh in? How much should we weigh into the data domain experts versus data science experts in your experience? Or is it case dependent or problem dependent?
Yeah, I would say it's a bit of a problem slash case dependent, which feels like a bit of a cop-out answer. So for example, when I joined my current team, which is identity verification team, I knew very little about the domain. So I was relying on a lot of the domain experts with the questions, initiatives that we're trying to drive. But then there were some other times when like my PMs, and I feel very lucky, kind of know that this is like my time to talk about A/B testing, how we should run things. And we have a constant feedback loop coming from each other. That's very positive. However, I've had situations in the past where there was an A/B test and I made a recommendation and my PM just decided to make a completely different recommendation that wasn't really data driven. And sometimes having something like a RACI matrix and knowing roles responsibilities helps. So in particular for A/B testing, I actually have guidelines of who is doing what, and kind of came to a conclusion that as a data scientist, I make recommendations, but a product manager is the final decision maker. So they can decide to do something that I don't recommend or don't agree with. It's less than ideal, but at least we know who's responsible for.
Got it. Thank you, Kasia.